Hello, everyone. This is the third week where we continue to start developing the teacher feature in the schooling system OtripleS. This last week was very eventful. A lot of people started pushing code, contributing. I've seen a lot of people quickly. It was really surprising to me how quickly they adapted to the coding standard and guidelines, and they just were able to start pushing in services and controllers and people reaching out, asking questions, trying to make sure things align together and all that kind of stuff. And I really appreciate all the effort that people have made, in the development of this project, the past development, the current development, and moving forward. Just a few things that I want to highlight so people would understand. If your PR is taking a while and there's a little bit of back and forth, that's not necessarily a bad thing because this is just the beginning of the project, and a lot of people are just getting acclimated to the guidelines and the coding standard, and they're just trying to understand, how things are supposed to be developed. A few people have told me that they don't quite exactly like the way we handle exceptions and the logging and tracing and all that kind of stuff, and that's totally okay. There are all different kinds of schools of thought, that go one way or another when it comes to dealing with one problem or another. And because we've started this project with a particular mindset, and we sent a bunch of videos, and I tried to get people to get used to the standard and guidelines that are going to govern all the coding that is happening through this project. It's really important to just give ourselves the opportunity to understand that standard and use it for a couple of features before we start saying, okay, there's this adjustment that we can do here or this adjustment that we can do there. There's also some people also suggested a few patterns, completely different patterns, and that might take a little bit longer because when you're working on bigger projects with bigger teams, just like this one, it might take a little bit of an adjustment and evaluation, especially that, if, I'm trying to push these guidelines and standardization. I can't just jump on a completely different pattern and tell people, hey, that's the new pattern, let's go start doing it this way without me trying it end to end in real multi-million user enterprise application first and know for a fact that this works end to end. A lot of ideas in the software world today, they sound really good and nice on paper, but when you actually start using them, and start actually embedding them in an actual software, you start, few things are going to occur. And that doesn't mean that any pattern that anybody recommended to me is good or bad. It just means it takes a little bit of time for adjustment and digestion and evaluation before we actually push that to be mainstream, how we're going to be building things moving forward. Um, I want you to remember this. The reason why we're doing this is that we're trying to help people, a lot of people around the world. This is not a reason for us to, have, few, conflicts or disagreements here and there about, how we're doing one thing or another. Feel free to reach out. If you are disagreeing on a particular pattern or particular guidelines, I'm more than happy to listen to your proposals and hopefully embed them because I'm also learning as everybody else in this project. We're learning from each other and we're trying to find the best ways we can implement a particular feature. Um, like I said, don't be frustrated that your PR is taking a little bit longer. We're very strict about our guidelines and our coding standard. Just because this is an open source project, just because this is a free a project that we're offering free, it doesn't mean that we're just pushing code in. There are going to be PRs, there are going to be code reviews, there are going to be very strict and vigorous process of reviewing the code. And I'm going to be referencing some people just go in and start looking at the code and make sure that it follows the guidelines. And the more you contribute to this project, the more you will understand how things work and all that kind of stuff. So I understand that few features were a little bit delayed and they were overdue, and people were asking me, hey, my feature, my work is dependent on that work, and that work is not done yet. It was really amazing to me and quite surprising also how the proactiveness of some people trying to actually push to the same PR to get it done, or just going in and saying, you know what, I'm just going to build the whole thing. Whatever dependency that's missing, regardless of who it was assigned to, I'm just going to go ahead and develop it and deliver it, and just so I can get to my part. These kinds of engineers are very, very special and very, very interesting engineers because they're like trains, right? You can't stop them, right? They will try to develop a task and they will see if this task is done or not. If they have a dependency and the dependency is not ready, they'll just jump in real quick and go build the dependency and then go back to their original task. I want everyone to learn and benefit from the example of these engineers because these kinds of engineers are, they're unstoppable. They're invincible, right? You tell them, here's your task, and say, okay, what's my dependencies and what needs to be done? If the dependencies are not ready, let me just go build them. But there's one little trick about being that way. You have to reach out to the person who has this task assigned to them and tell them, hey, do you need help? Are you stuck? And if they don't respond at all, then just go ahead and build the dependency. Because sometimes, just like everybody else around the world, sometimes things happen, right? Maybe they lost internet connection and they don't have internet for 3 days, or, they have a family situation, or, they got sick and they can't, they're resting in bed and they can't respond to emails or any of that. If you have a dependency and the person that, is supposed to, that I have assigned the dependency to, did not finish their work yet, send them a message and wait 12 hours. After 12 hours, if they don't respond to you, 12 hours should be conclusive of an entire half day. Wherever they are around the world, there should be at least 1 or 2 hours at the beginning of the day or the end of the day that they go in and respond and try to leverage Getter. Try to leverage Getter. Reach out to people on Getter. Say, hey, this task of yours is a dependency of mine. Do you need help with it? I'm trying to, push in my task. And, if people are not able or they don't respond at all, just be an invincible engineer. Be like those kind of engineers that are like trains. Nothing stops them to just pick up and go on their own merry way and make sure that things, are done correctly. So one of the tasks that I've seen two attempts to get a couple of tasks done, to get the same tasks done, which is the modification of a student. So if we go to GitHub here real quick, just gonna go to GitHub. I've seen people have made few attempts to try to get the modify student. There's the student modification and there's modify student done, and that's okay. It's not that people are not aware or anything. It just means that there's few things that needs to be tied up. Where exception handling, all that kind of stuff, and that's very important. Believe me, any engineer out there in the world can very simply write code that adds in records to the database and retrieve records from the database. I can promise you like that right now. There are 11, 12, 13, maybe 14-year-olds that can do that. What distinguishes an engineer from a coder, and I want you to pay attention to what I'm saying here. What distinguishes an engineer from a coder is that you're thinking about the whole process and you're thinking about the edge cases. Right, the edge cases, the permutations of things. What if the database is not available? What if I can't access the database? What if I'm running into a database locked exception? Like right now, I can't access the database because some other process is updating the same record. That's where engineering lies. Building something end to end and building a pipeline and posting a student and retrieving a student. I can guarantee you right now, anybody can do that, right? You could go on Stack Overflow or watch a couple of YouTube videos and that's great, right? But all the magic happens in the edge cases and the modularity of software and all that kind of stuff, and that's what I want you guys to pay attention to. The actual logic, that's easy, that's nothing. The exceptions around the logic, what happens with our dependencies, that's really, really what matters. So I'm just going to pick up one of these tasks because it's overdue, and I'm just going to go ahead and try to make it happen. Before I do that, I've noticed some people just went in. I think some instances of Visual Studio will do that for you. I'm just gonna go in here and just make sure that this is just SDK. So I make sure that this is a test project. See the icon here changes real quick. I want to make sure that this is actually a test project. This is not a web project. So let's take that guy out like this. So that turns both of these projects to tests. And believe me, these icons are very important to some people with issues with dyslexia. They can't see things and all that kind of stuff. It's really, really important. So it's just, this is one little change, So I'm just going to put a commit in here and say change, project. What is it that we changed? It's basically called the project target SDK. All right, so we have that stuff. It comes in with good stuff. So see, I'm taking a step and I'm making a commit, and that's really really important when you're taking steps like these. It's really really important that you commit every time you do something that's idempotent or atomic, right? They write a failing test, commit. Make that test pass, commit. It just shows that you're actually test driving the software instead of just shoving code in. You know, your commits have to tell a story about how you built that software. Yeah, and that commit history, when I look at a commit history, like, and I'm going to show you now, um, one of the contributors in this project. This is a PR that we closed in here that was merged about registering a student, for instance, right? So registering student, look at this PR. This PR is ideal, right? The PR that Viral pushed into the repository is ideal. Why is that ideal? She's showing you that she have tried things end to end. So she built the entire controller with the service. And then if you look at the commit history, you'll notice something really, really interesting there. The commit history basically tells me the story of how she actually built the software. So you will notice in here it says should register student by ID async. If you go into here, you will notice that she is building a test, right? She's building a test to make sure that the student, this is the test, there it is. Should register student by ID, right? So basically she's writing in a test, right? And the test will basically fail because there is no registration. Like right now, if we go into I can guarantee you right now, here it is. So she wrote a not implemented exception method, right? It says register student async, right? And in that not implemented exception, she basically built an interface, and I'm going to show you that right now, step by step, and I want everyone to be on board on how we're building software because your commit history has to reflect how you actually built that software. She built a method, and that method throws not implemented exception, and then she went back to the test, and she said, I'm going to write the test first to make sure that this test, and let's go through that test for a second there. It says that it has a get current date time, right? And then you have in here the setup for inserting a student. And then in register student, we're making sure that when we register the student, whatever was returned from storage after the insert matches, what came back. So actual student should match expected student. Let me go through this a little bit. So she created a random date time. She created a random student. That's a little method that you pass in date time to it. So you can just create the created date and updated date. And we'll come back to this one. And then she created an input student. She created storage student and the expected student. Someone might say, well, they're all the same variable. I'll be like, I understand. I agree with you. But in the language, when you're reading the code, you're saying storage broker mock returns async storage student. If you say in here returns input student or returns expected student, it's kind of weird, right? Because the storage broker is returning a storage student, right? So while you're reading the code, your code should be like a symphony, like an orchestration, right? You're reading the code and it's easy to follow through. See in here, she said register student async input student, which is the same thing, except that the language is better, right? And then at the very end here, she said the actual student should match the expected student. If I put anything in here other than expected student, it's just going to sound weird, right? If I say actual student should be equivalent to input student, that just doesn't make sense, and it's not true. It's simply not true because it's not the input student that comes back. It's what actually has been persistent in the database that actually comes back to us. And that's what we actually equate to and validate with. And then at the very end here, she's verifying that no other dependencies were called and all that kind of stuff, which is all good and dandy, right? So this is insert student, all things are good. And then I expect to see the next commit that she made. I'm not saying push, it's a commit, right? The next commit, she will only be modifying the register student async. She went in here and she said return away this dot storage broker dot insert student async and then pass in that student, and that's it, right? That's it. That's the entire method. She made the call, she made the asynchronous call, and then that made the test pass. Red, green, refactor, red, green, refactor, red, green, refactor. So, okay, so this is great. Let me just go ahead in here and pick up one of these tasks that are kind of stuck, and let's write one from scratch, right? We want to modify a student object. How do we go about doing something like that, and how do we make something like that pass? And I want people to pay very close attention because that's how we're going to be building our software moving forward. We're going to have a lot of entities. I know there is, at least 20, 30 entities, and each one of them will require CRUD operations and orchestration, and it's a big project. It's a very big project, and it's worldwide, so pay very close attention to the stuff that we're doing here and learn. Learn while you're at it. Learn something new. Be a part of a group of engineers from some of the biggest companies around the world and the biggest places around the world. Learn from that. There's at least in the accumulation of experience, there's at least a century worth of experience in the accumulative experiences that are the people that are contributing to this project. Imagine it's like sitting in front of someone who has been doing C# for 100 years. There is a lot to learn there, and that's why, I want this project to be better. You'll also notice that, we really care about the copyrights. And I call you guys the coalition of the good-hearted engineers. Because you are a coalition of good-hearted engineers. You want to make sure you put in that there at the top in every line of code, in every file you're doing, to make it very clear what the purpose is of this code, and whoever uses this code, it's free to use as long as the software funds are donated to the poor. It's very simple, right on point, and it is, what it is. All right. So, okay, the first thing I want to do here, I like to follow the pattern of the CRUD operation. We say CRUD, create, retrieve, update, delete, CRUD, right? Which means that our methods here should follow that exact same pattern. You will see that when I was putting together the storage brokers for the students, you will notice that it's following the same pattern. CRUD, create, insert, select, update, delete. CRUD operations. Let's do the same thing with the service. There have to be some logic, some orchestration, some thought put behind why you're naming your variables, why you're ordering these methods. Put some art into what you're doing. Don't just shove code in and say it is what it is. That's just a recipe for a code that will be very, very hard to maintain and very hard to work with. All right, so CRUD operation. So register goes at the top because it's doing the creation, and then retrieve, obviously, so it's retrieve student by ID, and then there's the delete. Fantastic. I'm just going to go in here and add modify student. And you will notice the language here is very different between here, modify student async, and it takes in a student model. Here's a student, and that's it. So the language here changes a little bit. Someone might ask me, Sid, why didn't we say insert in here? I say that's not that's not a broker. It's not a database language. We're trying to speak business language. We say register student. We don't say add student. We don't go to school and say, hey, add my son to this school. No, you say enroll or register my son or my daughter in this school. So register is the language that these services speak. They speak business language. They speak human language. They speak language that's easy. If I pick this up and say, hey, we're retrieving all the students from the database, it'd be a lot more easier to understand than saying, hey, we're selecting all the students from the database. If you go to a complete stranger that doesn't understand technology and say, I'm selecting all the students from the database, we're selecting them for what? Right? They don't understand the language. Maybe some of them will, some of them won't, but definitely not all of them. But when you say I'm retrieving all the students or retrieving a student by their ID, it makes much more sense, right? So, all right, so modify student async. Let's go in here. Obviously, this guy will be sad. Why it's sad? Because we haven't, implemented the method that we promised we're going to implement. And while we're at it, let's just pick up these methods as well, and let's order them by the CRUD operations standard. So this guy goes at the top. This guy goes a little bit below. Let's take, if you're wondering how I'm moving the methods like this, you just do Alt, and then you just move up and down. The up and down button, it will move the entire block of code upside and up and down and all that kind of stuff. So right, delete is the last one. We want the register to move it all the way at the top like this. This is great. Let's make sure there is no, see, this is not okay. You want to make sure that there's one empty line between your method and the next method. Anything that's two or more liner, multi-liner, make sure you break it with an empty line. And then there's register, retrieve, CRUD, and then there is the update. And then there's an additional line here. We only just want one empty line in here. And then you have the delete. All right, we have all of them. It's great. This is fantastic. All right, let's go write a test. And our test here will say something as simple as use control MO. If you do MO, it basically helps you collapse all the methods so you know what's what, and then let's move the register student at the top. Just again, CRUD operations, nothing serious. This is CRUD, and then this is retrieve. Let's put that guy up there. And if this is delete, should delete student. And while I'm at it, I think this should say should register student async, not by ID. All right, so just control period. It will rename the entire thing, and everything is going to be good and dandy. All right, so here's the test that I want to write. Fact, you will notice that I'm cleaning as I go. This is called the Boy Scout rule, right? It's code rubs, right? Yeah, as you go, you see something wrong, just fix it while you're at it, right? Leave it better than you found it. Boy Scout rule, right? All right, so let's go in here and type async task should modify student async. So the first thing I'm typing here is the happy path. The happy path. Happy path meaning everything is good and dandy, there are no issues, and we're trying to create a random student, and we're trying to make sure that this student is, you know, matching the guidelines, right? So let's go ahead in here and say given. So this is when I set up my test, when, and then. Set up your test here, run your code here, and verify in here. Some people say assert, assign, assert action, arrange, assert, something like that. Arrange action, assert. There's all different kinds of thoughts, you know, when it comes to that. For this project, we're going to be using given, when, then, which is the same exact language that I use even when I write user stories. It's much easier for the engineers to look at something in the user stories in the Azure DevOps and just look at the code and say, yeah, I know what needs to be implemented. It's a lot easier language. All right. So should modify student async. So I need to create a random student. Random student. Create random student. Here we go. So I want to create an input that I want to send downstream. And this random student takes in what? It takes in input parameters. And it takes in input parameters because we have to validate downstream that this student, you know, is like the created date and the updated date on this student, they have to be within 1 minute before or after now, right? So we're giving 1 minute of communication grace period to persist a record. Anything beyond that, you know, it would be a false record, a record that is invalid. Some people might say, why don't you let the server take care of the generation of the updated date and created date? And the answer to that is if you're running, so this is great on paper. Oh, let the server take care of the created date, updated date, everything is good and dandy. But then let me ask you this, if your system is going through migrations and you still want to honor your validations, how do you go about doing that? Right? Because if you want to migrate data, you still want to honor the dates. You want to only turn off the switch and turn in the switch on creating the updated data and created data instead of having them generated for you automatically. It'll be much easier to disable a validation rather than disabling a persistence in the database where you generate, you know, the dates for created date and updated date. All right, so that makes sense. Let's go in here and say date time offset. And this is a random date. And let's go ahead in here and just create random date or get random date. We don't create date, it's just we get it, right? And in here, I'm just going to go and say this guy takes in dates. Instead of saying now, I don't really like the name in here. You want to say this dates. Dates meaning that we're going to assign this to both created date and updated date. Down the stream, we're going to change this a little bit, you know, because the updated date should not match the created date when you're creating a record. We'll come back to this one in a second. So this is random date, and I'm going to go in here and pass in dates. This is random date. All right, so what I created my random student with random date, I'm going to use that date to tell my service what now is, because we're going to downstream go and validate what now is. So in here, I expect something just as simple as going in here and saying this dot datetime broker mock. This dot datetime broker mock dot setup broker dot get current time should return that random date. So now I'm telling my service, if you go back to your service, you're fooling your service. You're telling it, you know, now is whatever random date I created. You're Doctor Strange and from the Marvel universe, right? You're convincing people what now is, right? Based on what you think it is, right? So the reason for that is that you don't want to have hard dependency on the actual date time of the system or the server that you're running in, because that's a dependency. You're not really completely mocking all the dependency and only testing your business logic. Instead, you're relying on an external resource of data, even if that data is the air in the room, including the time and any of that. So you want to mock that. You want to mock that part. All right. So just as simple as that, you said I'm creating a random student, and I'm telling my date time broker, that now is whatever random date I created. All right, this is all good and dandy. Now let's create a couple of more variables in here. Student, input student. My input student is nothing but the random student, but I intentionally create these variables so the verbosity of your test is a lot easier to read. And I'm going to show you that in a second. I'm going to pass input student, get storage student, and then validate expected student. Right? So they're all the same variable, but the language, then the name of your variable makes sense when you're reading the code. Your code has to be just as pretty as your interface. If your interface is pretty, if your interface is not pretty, we have a bigger problem than just naming variables. So let's just go in here and say another student, and this will be storage student. Now be careful there. Storage student here is a little bit tricky because I want my storage student to have a different date than the input student. When you're throwing in an input student, your updated date can never match the updated date on the student in storage. Because if it did, that means that there's an error going on. There's no way on God's green earth that you will be able to post two students in a row and they're going to be exactly the same time, especially with a date time offset that you're measuring down to the millisecond. Right? So let's just go ahead in here and say this storage student is whatever that random student is dot deep clone. And I assume the library is not here, so let's just go ahead and fix that. There's this really nice and sweet library. I'm going to show you that library in a second. Manage NuGet package. Deep cloner. And I'm going to add that deep cloner in here. All right, we have deep cloner, and then in here I could just go and say, I think it's either clone or deep clone, something like that. All right, why am I using this deep clone? Because I want the reference of this guy to be different than the reference of this guy. So when I change things in here, they don't match things in here. And I'm going to show you that in a second. Okay, so I'm adding this guy, so that means that my expected student, right, equals my input student. Okay, so there will be two storage students in here, the one that we retrieved originally and the one that we persisted and then it came back to us. So this is before update storage student. This is the one that's before update the storage student, right? But then there is another one in here after update storage student. And this after update storage student should be exactly the same thing as the input student. And your expected student should be exactly the same after update storage student. So the definition here is telling you a story. It's telling you a story. What's the story that this definition is telling you here? I'm going to tell you in a second. Let's move these upstairs a little bit. Yeah, there you go. You sent in a student. This is the student that you got after update. Actually, let me keep the... So you sent in a student. The service went and tried to pull in the before update storage student. So it cloned it and it said, okay, this is something else. And then this is after update storage student, and then this is the expected student. Let me pull this guy down a little bit, and let me do a slight change to it. The input student dot updated date, watch, equals storage student before update storage student dot updated date, and then I'm just going to add random number of days there just to make sure that this is exactly something that cannot fail my validation logic. Something that cannot fail my validation logic. So let's go in here and just create random number of days. Integer random number, get random number, like this. And in here I'm going to go and say random days, which is a random number. People say, why don't you just assign random days? And we're like, well, you know, you want to tell the story, right? So you want to say this is a random number, and my random names are coming from a random number. And then in here you want to go and say days, random days. I like it when people use the aliases when they're building their code. So you make sure you want to build your alias when you're building your code. All right. So this is that. This line does not exceed 120 characters, so it should be good to go. Now, I have before storage, after storage. It's all good and dandy. Let's set up some stuff, right? So in here, this dot storage broker mock dot setup broker dot update. First of all, we want to say select student by ID because we're going to pull that student from the database. We're going to pull that student from the database and we're going to compare what's in the database versus what's actually there. So this is select student by ID. And we can obviously get the ID from, let's just create a variable in here and call it student ID all the way at the bottom here. Here's a GUID student ID equals input student.id. Some people might say, well, we have other IDs that we want to validate based on. I say, I agree with you down the road. Don't worry about it now. Just build the foundation, right? So this is student ID. So when I'm passing in a student ID, it should return what? Returns before update storage student. So when I call the database, this should be returns async actually. Returns async because it's all asynchronous. So I'm returning the student that came back from the database before I actually made the update, and that's totally okay. It will be it will be very, very different from the actual input student because the input student has completely different reference, and we said that the updated date on the input student is going to be a lot different than anything else. All right. So this is the setup. There's another setup that I want to do in here. This dot storage broker mock dot setup broker dot update student async, and in here I'm passing in the input student, and it's returning async what after update storage student, like this, right? So there is two things that we know is going to happen one way or another, even when we're working with the happy path, right? There's two things that we know are going to happen. The first thing that's going to happen is that we're going to try to pick up that student and compare dates eventually down the road, you know, and the other thing in here is that we know we're going to call the update student async. Great. Let's go in here and say student actual student equal await this dot service, which is the service that we're testing, and then modify student async and then pass in the input student. See, because I did my setup right, it's so much easy to know what I'm passing in, what I'm returning. This is the before update and this is the after update. We know all that kind of stuff. It's very easy, right? All right. So this is the call. Now let's go in here and say actual student should be equivalent to expected student. That's one thing. Number one thing. These should be equivalent. Right? What's number two thing that we want to care about? We want to go in here and say this dot datetime broker mock dot verify broker dot get current datetime. This guy have been called at least once. So I called this guy once. I'm verifying that I called my dependencies appropriately, as they should. right? The other thing that I want to do here is that I want to go here and say this dot storage broker mock dot verify broker dot select student by ID, right? And this is student ID in here. So you see, it's easy. It's like you're writing a symphony. Has also been called once. That's another one. Okay, that's the second one. Oh, perfect. This is all great. Let's move on to the next thing. What else do we want to verify? We want to verify that storage verify broker dot update student with the input student passed in. It should have been called once. So I'm not just verifying that I got the right information. I'm verifying that my dependencies has been called right and they have been called with the right input parameters. Some people go to the extreme and say they have to be called in order. I'm okay with that. I think it's a bit extreme, but I think it's fine. In some cases, it's really, really important. In some other cases, it doesn't really matter, right? So in here, we want at the end to say we want to verify that all our mocks, our dependencies, have had no other calls have happened other than what we actually explicitly declared. What we declared is going to be called, and we verified that it's going to be called. Nothing else should happen. Absolutely nothing else. All right. So this storage broker mock, and this is datetime broker mock, verify no other calls. And this dot logging broker mock, verify no other calls. Perfect. The last thing I want to do here before I do any of that, I want you to understand something. The way we set up things in here is the exact same order things are going to be called. So one thing I forgot to do in here is that I want to be able to go in here and say this actually is getting called before this. The select student by ID gets called before the datetime broker for validation, and the select student in here comes in before that datetime broker for validation. All right, I have a test. Should modify student async. If you do Control RT like this, it should show you that this test has failed. This is one failing test right here. Failing. And why this guy is not failing? Because we're test driving this, because there's no implementation have taken place, absolutely nothing until the test is passed. This is test-driven development. So I'm just gonna, after I have a failing test, you go and do right-click, commit, and you paste in the test name, do a thin arrow like this, and say fail all capital. So that means here's the first step in my development. I have written a failing test. I've written a failing test. So let's commit that one. So I have a failing test, great. Now let's go and make that test pass. How do we go about doing that? Very simple. I have a student in here, right? And this student, basically, this is storage student, right? And I'm going to go in here and say await this dot storage broker dot select student by ID async, and that's my student.id. So here's the first call I made. What's the first call I made? I'm trying to pull that student from the database to start validating what's in storage versus what's in my hand. But I'm not going to do anything with that yet. We'll come back to that one. So okay, I have storage student done in here. It's great. The next step I want to do is that I want to go in here and say, like this, I want to go here and say the return await this dot storage broker dot update student async, and this here is the student that I am waiting for. Right? This is the student that I want to validate, but I didn't run any validations yet. And I'm going to show you now what I'm going to do with that in a very, very short second. In here, while I'm at it, I'm just going to make a call in here. I'm going to say this is now, and I'm going to call my datetime broker, and I'm going to say get current datetime. You'll notice I'm not doing anything with the first two variables, absolutely nothing. But it's going to help you a lot down the road I'm only doing this because this is very familiar. But ideally, you're only calling this guy and saying this is the happy path, move on, and the world is good and dandy. But I don't want to go back and validate my test. So this is how I'm building it. Now let's run the test again. You say we have the red stuff right here. Let's just run this test again and see if that pass. If it makes our test pass, then we're good. If it doesn't make our test pass, then we have a problem. Here we go. And the test pass. See, this guy right here, it's green. It's saying, yep, absolutely, you have fulfilled all the conditions. And this test is passing. Fantastic. What that means is that you want to go, after we've made that test pass, we're going to copy the exact same test name, which is should modify student async, single arrow, and say pass. Now, if you look at my commit history, you'll see a story. You'll see a story. What's the story that I'm telling in my commit history? Get log 2. You'll see that there is a part where I made the test fail at 17:23:55, and then 17:26:28 I made that test pass. That's how you're basically telling the story of how you develop the feature as you go. Some people might say, well, there's POC, I want to try things out. I said, absolutely. Before you commit anything, try the world, make sure things work. But what matters is that when you're actually committing code, you want to write a test and run it and make sure it fails. And then you commit that it fails, and then you write another test. And you commit that it and you write the logic that makes that test pass, and then make that test pass. Right? By the way, just letting you know, the modify anything is the heaviest, hardest task in any CRUD operations. And I'm actually very glad that people, were going back and forth on it, so I can show you the hardest thing. The select all, select by ID, add, stuff like this. It's nice, but it's not really that crazy. The one that you really want to, pay attention to is the modify. So I'm very glad that I had this opportunity to show people what this is like. All right, fantastic. Let's go on to the next test, right? What's the next test like? We're going to write some validation tests. You'll notice that people were doing validation.add, validation.retrieve. We're trying to separate the tests and the files. So when you're actually looking for testing something, it's a lot easier. The rule here is simple. If your code is exceeding 200 lines, I'm pretty sure I saw something in here that exceeded. If you see that it's touching on 200, 300 lines, stop breaking. Stop breaking your code, right? Stop breaking your code, making sure that your code makes sense. Right? And we could probably simplify this a little bit. I'll come back to that and do a code rub. If you're not familiar with code rubs, I'll explain to you. Just read the links in the getter, just search online for any of my articles. You'll see code rub in there. It's very, very important. Let's add some copyrights notice in here. If you do Alt Enter, it will add the banner for you automatically. So you want to make sure things look right before we move on with anything, right? Okay, so here's the copyrights, you have everything. Okay, let's create a new file in here. And this new file, we will call it student service tests dot validations dot modify dot cs. So a special file just for all the validations that surround the verify and all that kind of stuff. So let's just control period in here. And let's write our first public partial. We rely heavily on partial classes to represent different aspects, excuse me, of the code that we're trying to write. Let's write our very first validation test, and watch the language that I'm using to write the test. I'm gonna go in here and say public async task. We want to say about what should happen, when it should happen, where it should happen, and then when it should happen. Remember this. What should happen, where it should happen, right? When it should happen, right? So let's see what that happened. Let's see how that works. So I'm going to go in here and say should throw validation exception. That's the what. On modify, that's the where. When student is null. And log it async. Here's one test. So if the student that's being passed in is null, it should throw a validation exception. It should say null student exception. And that should be wrapped up in a validation exception and kicked out of the service with this inner outer exception. So let's do this. Let's say given, when, then. So here's a student, right? I'm going to call it invalid student. And this invalid student is null. Invalid student is null. Okay? And then let's write the exception that we expect. So var null student exception equal new null student exception. Someone might say, where did you come up with this null student exception? My friend Viral, before she did the registration and all that, she already took care of all that, those little exceptions. And hopefully there will be another session where I show you guys. So this is null student exception. Okay, this is great. And it's null student exception. And then inside that guy, we're going to go and say, you know, student expected student validation exception equal new student validation exception that takes in a null student exception internally. So you will see that the big exception, the wrapper exception, talks about either it's a dependency or a service or a validation. Any service can't come up with anything other than these three things. Is it dependency? Is it processing? Or is it validation? And then inside of that exception, there is the details. The inner exception will tell you why this is a validation exception, why this is a dependency exception, and why this is a service exception. And I know I'm throwing a lot of things at you, so I want you to slowly read this and ask me, just gather notes and ask me any questions you may have. This is a big standard through the years, 20 years worth of software experience. I want you to ask me questions. I want you to learn what this is. Even if you don't want to contribute to this project, even if you don't want to be a part of it, ask me questions and learn. Ask me questions and learn. So, okay, expected student validation exception. And then what we really expect here is that what's going to happen is that, you know, when the student that's being passed in is null, that means that no dependencies will be called at all. At all. Which means that I can very safely go in here and say, this is a value task. You notice I'm not saying this is a student, this is a value task, because I'm trying to capture the process itself before it executes and throws an exception, and I'm going to wrap it in an assertion statement. I'm going to show you that in a second. This is modify student task. This is not expected or actual or any of that, because there will be no student returned if you're passing in a null student. So instead, in here, I'm going to go and say this. Notice that I'm not doing await either. I'm not doing an await either. In here, I'm going to go and say service, modify student async, and I'm passing in here invalid student. So I'm passing in invalid student to my function. And I'm saying the expected behavior that will be some student validation exception happening. How do I do that? You can go in here and say await assert throws async. So this guy is going to throw a student validation exception when we call this modify student task as task. So I'm calling this modify student task, and I'm running it, and when I run it, it's going to throw an exception. So I'm saying assert that this guy is going to throw student validation exception. What else do I want to verify? I want to verify two things. I want to verify that my logging broker have logged an error of an exception that is exactly similar to same exception as what? The expected student validation exception. And that should happen only once. That's the first thing I want to verify. I want to make sure that when this exception happened, it happened once and it matches the same exception. Someone might say, why same exception as? Why don't you just pass the expected exception? So that's a great question, because it's a different reference. We created our own exception in here, but the surface is going to go and create its own exception. So they're going to have two different references in memory. So instead, we say same exception as. Someone might say, what is this same exception as? It's just an expression. It's just a method in here that says validate that the exception message matches the message, and validate that the expected inner message matches the message. That's all that it is. It's just a method that says this exception has the right information in it. There's another thing, though. When it's being thrown with the stack, it has more information than what you can generate from a method. So it's really important, that you just look at the things that you care about. All I care about is just the message and the message. Whatever the exception may be, it doesn't matter. I want it to say exactly the right messages. That student is null. Like if you go inside this exception, it'll go and say the student is null. The past tense student is null. And if you go inside that validation Uber exception, it'll tell you invalid input, contact support. Right? Contact support, talk to the engineers, tell them what's wrong. Every time I'm clicking the button, it's not working, and then we'll go look in the back end and say, oh, you're posting in a null, something is wrong with the UI or whatever the case may be. All right, we have that stuff. Now, the last thing we want to do is that we want to verify for every mock, verify no other calls. So the first thing here is the logging broker. The second thing that we expect to happen is the storage broker, but that's not going to happen. So we're just going to go and say, ideally, in an ideal situation, chronologically, the storage broker would be the one being called, and then there will be the datetime broker, like this. And then I think that's all. That's all our dependencies right here. See, the order of things here is really, 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 really important, and I want you to pay attention to it. All right, so let's run our test in here. And the expectation is that this is going to blow up, obviously, because, we're passing in a null student and we're validating few things, and these things are not matched. So watch this guy go red. There you go. And then you run and run. And then we run again, and you will see in here it says, read the message. The message here is very important. It says, I expected you to throw a student validation exception, but what I actually received is a null reference exception. Why? Because the service tried to actually process that null student and it didn't work out, right? Because it's null. So now, just like we said with every other thing, I'm going to go here and do right-click commit. I'm going to put in the failing test, fail, like this. And then let's go and make that test pass. How do we make that test pass? We're going to go into the modify student async, and we're going to do a couple of things. We need to validate that this student is not null, right? So I'm going to go here and say validate student. And this validate student basically will take that student in there. And it's very likely that Varal already have written something. Yeah, there you go. Validate student, and student is null. It throws a null student exception. So this method is already in there. All right, I would have wished that I would type it all, but she beat me. She's very fast. She's very smart. So there it is. So if I put that in there, that's not enough. Why? Because I don't have the handling of the exceptions in here. I need to wrap this up in a try-catch statement. Try-catch. And how we do try-catch is very different than what you think. We abstract try-catch away for a reason. The reason of that is that we're trying to make sure that the try-catch statement, however big it is, because we're going to be handling a lot of cases, the try-catch shouldn't convolute your vision, should not consume your cognitive resources when you're looking at the logic. If I want to look at the logic, I want to look at the logic. If I want to see what exceptions we're handling, I could go right-click and see all the exceptions that come from the database. And I'm going to talk about all of these exceptions in a little bit. There's some of these exceptions are not there yet. We'll talk about that. And this is what makes an engineer, is that you're handling all the edge cases. You're building industrial, invincible software, if there's ever such a thing. There will always be cases that we don't know about, and that's why we're learning. We're forever learning and forever working with each other. So let's go back here and say this is try catch, and I think I missed one tiny detail in here. This is return try catch, and I know this try catch is basically a delegate, and so yeah, I just need a semicolon in here. Right, so semicolon, one statement, it's all done. Now if I go back and run my test, see if you click on that red guy, and then you run, watch this guy go green. There you go. Green. It passed. Why did it pass? Because we are test driving things and we are writing proper software. Should throw validation exception on modify when student is null and log it async. So we wrote the test and the test failed First of all, let's just clean something up. If there's a one-liner in here, remove the lines between one-liners. If you have two-liners, just keep a space between. It's easy for your eye to read. Even if I zoom out really far like this, I can tell you what's going on in here. All right. And before I do this, let's just clean up. So a lot of people ask me, how do I do cleanup? You do right-click, analyze, and then run code cleanup, and it'll just take care of all that stuff for you. One more thing for people who are watching this. If this is the first time you're doing this, make sure you go to General, type in System, and make sure that when you do code cleanup, it places the system directives first when sorting usings. So it'll put the system calls at the top, and then everything else come at the bottom, because these are the native libraries, and it's a lot easier to. It's just a guideline. So now that we have this passing, let's just right-click in here, do commit. There you go, and then I'm just gonna say pass, like this. This is gone. So fail, pass, fail, pass. What's the next thing that we want to validate? This is, the modify is a nice story, because the modify tries to check for a few things, and let's pick up the next thing. The next thing here is something just as simple as validating the actual structure of the student model. So let's just go here and say fact public async task should throw validation exception on modify when student ID is invalid and log it async. What does that mean? You're getting in an empty ID, for instance, an empty GUID, and you're trying to validate that case, that edge case. You want to pick up that one, right? So let's go in here and say given when then. Great. Let's create a random student. Random student. Create random student. And out of that random student, I'm going to create an invalid student. Invalid student equal random student. Here you go. And then in here, I'm just going to define something that says invalid student ID equal GUID.empty. Right? And this guy is asking me for dates and stuff. What we can actually do, because some of these cases don't really require a date, let's write an overload for this that doesn't really care about the date line. So let's just go in here and say create random student private static student create random student, and this guy doesn't really take anything. And let's extract away that filler for a second. Let's take that filler out. Create student filler like this, and this guy returns a filler. Instead of create, let's have it return the actual filler, and this is my filler right here. You probably want to use static with these methods if it doesn't, especially if it doesn't hold a state, right? And because this is a one-liner, we could just go in here and say this is a one-liner fat arrow function. You don't need to scope what doesn't need to be scoped, and then this is create, and this should be good. So that's one guy. Let's get the other guy. The other guy we'll just pass whatever dates we want in there, because we don't care. It doesn't really matter. So create random student, and in here I'm just gonna go and say, sorry, create student filler. Create student filler, and this guy takes dates that are, I don't care, date time offset dot now or UTC now, whatever the case may be, and then just go in here and say create. So these are two different things. One of them just passes in the value. The other is saying, no, I want this to be passed in so I can control the validation. One important thing I want to talk about in here is that you want to pick up this guy, the fillers, the things that are least to be used outside of this file, and they take the lowest priority. We'll put them all the way at the bottom. Why? Because when I open up this file, I want to be comfortable seeing only the methods that I care about. And I see a lot of people leaving empty spaces like these. Please don't do that. That's not clean code. Just make sure you clean things up. These one-liners are stuck together because they're one-liners. Multi-liners, they have their own space. It's all a bundle of bunch of rules, right? All right, so we have this guy. That's great. And let's go ahead in here and let's just say this is create random student, and this is just an overload. This guy doesn't take an input parameter. All right, so I'm creating this guy. This is random student. And in the invalid student, I'm going to say the ID, assign the ID to be invalid student ID. Invalid student ID, which means that this will trigger invalid student exception, new invalid student exception that takes in a parameter name, name of, don't write strings, don't hard code strings ever, and in here go and say student.id, and in the parameter value, which is an object, it'll take the invalid student ID, which is the value that comes in from. It's actually better to say invalid student.id. We're basically pointing exactly the exact exception that could come out of that. All right, there's a bigger exception here, expected student validation exception. And in here, we're going to go and say new student validation exception. And this guy will take invalid student exception. So there's the inner exception, the little story, and then the big story that wraps all of this and shoots it out of the service. Just like we did with the other one, we're going to go in here and say value task, student, and this here modify student task, which is this dot service dot modify student, and we're passing in here the invalid student, and we are intentionally keeping that name because it's an invalid student. And then we want to validate that this actually happened, right? This might be very, very similar to the stuff that we're doing here. So I'm just going to copy that block in here as is, and I'm just going to dump it in here. Exactly the same block. We're asserting that student validation exception has been thrown. We're logging that the same exception that matches this, and we're making sure that nothing else was called during the process of building this. All right, here's another case. So let's go ahead and do Control RT. And this guy is failing. Why? Because in here it says, I expected that a student validation exception would be thrown, but instead nothing was thrown. See, that's the edge case. If you run your application without these validations, your application will say confirmed. Good. Good to go. Right? When your application is actually allowing invalid values to be passed into the system. You don't want to do that. Right? So let's just pick up this guy that's failing test, and let's just go in here and go do control commit. And let's go in here and say fail. Again, just a story. We're telling a story through our commits, right? All right, let's make this guy pass. How do we gotta make this guy pass? Let's go to the implementation of this guy. And in this implementation, we want to go and say validate student on modify. You'll notice that Viral put something interesting. He says validate student on create versus validate student on modify. Why is that? Because the validations that you run when you're adding in a new student is very, very different when you're validating a student on, an existing student in a database that you want to validate other particular things. So, all right, let's just go and create a new method in here. Private, static, void, validate student on modify. And we're taking in here the student itself. And we're going to run some validations. This is it's not supposed to be static because we're going to be calling the datetime broker, which is a private class member and a dependency that requires a state. So we're going to take out the static out. Validate student on modify. So let's move in this guy, the validate student in, just like Viral did. We're going to move this guy in because we're going to be adding. And then in here, we're going to say validate student ID. We might actually later go and say, there are common validations that we want to agree on. And okay, so in here, validate student ID, where is the method that does that? Validate student ID is all the way up there. And, instead of doing that, I really like to say student. Oh, it's validate student ID because it's being used publicly in the select by ID. I got it. Okay, perfect. All right. Okay, perfect. So let's go in here and say, okay, this is student.id, right? I'm okay with that. So validate student ID. which is a method we're all already built, will go and throw that exception for me if that ID is not valid. Is that the case? I don't know. Let's go back to our test. Control minus, control minus. I'll take you back to where you were. And here's my failing test. I'm going to go and do control RT. There you go. And this guy is failing still. Let's see why. Oh, because I forgot to make the call. See, this is really, really good because in here I forgot to say validate. So in here, validate student on modify, and we're passing in the student, and it's all good and dandy. Now we expect that test to pass. Let's go ahead and run this test. Run them all. What basically happens is that it's going to run into that exception, shoot it back to the exception handling, and then see that guy passed. Why? Because in the try catch, if you go, let me just explain what's going on so people would understand. When you go into validate student by ID, it basically throws during validation, if the ID is invalid, it'll go and say invalid student input exception. What happens to that exception? It gets taken care of by the try catch block that will take invalid student input exception, right? And then turn it into create and log validation exception. So it takes that exception and then it calls it, it passes it to this method here. And what this method does is that it takes that exception, creates a student validation exception, and logs it, and then returns that exception to be thrown to the outside, whoever is calling this service. And this is why I was telling people, don't handle exceptions all the way at the top. That's not really, really smart, because there will be a lot of stack that you have to go through in order for you to find where the issue is, versus a logger that tells you exactly on spot where the problem happened. It makes much more sense and makes it a lot easier to find problems this way, especially if you're sifting through the logging at 3 in the morning trying to fix a problem that's breaking some 50,000 users. It's very, very useful. So okay, so this guy is passing, great. Let's go back to our guy here and let's just make a commit to say, yep, this guy has passed. This is validation modify. Let's go here and commit and push this guy as pass. Let's take a look again at our history. Should be proud of what you're doing here. Git log, the last two commits was this guy failing at 1748 and then 1753 this guy passed. Clean code. You're pushing pure code. You're pushing something that's failing and then making it pass, and you're telling the world how you built that software. Let's pick up the next thing. You know, what's the next validation that we want to do? There is modify student async. Let's go back in here. What's in the student object that we want to take care of? Let's say the person that's passing this, there's a bunch of strings in here. And we don't want any of these strings, maybe except for the middle name. We don't want any of these strings to be, you know, null or empty or white space or whatever the case may be. Right, except for the middle name, I understand that. And I think some people actually don't really care much for the last name. I know that some people have just first name. I've heard about that. Not quite sure. So how do we take care of that stuff? We want to handle all the string cases that we have, whether they are null or empty or white space. Right, let's go ahead and write a test for that. It's going to be very similar tests actually. Validation retrieve. In this case here, we're going to do something else. We're going to use a theory, and we're going to use inline data, and we're going to put null like this, and then empty string or white space, whatever the white space is. And then in here we'll say public async task should throw validation exception on modify when, you can also say if, when student what's the variable we're trying to validate. If you go into student in here, the user ID is invalid, and log it async. Are we still under 120 lines? Yes, we are. So this is one test that's going to cover all the bad cases that may happen. And in here, I'm just going to type here string invalid student user ID, and because this exceeded 120 characters, you want to break that. So people don't go scroll right and left, especially on their laptops. You want to break at 120 characters. All right, and then let's go in here and say given when then, like this, and then let's just start typing the stuff that we want. So I want to create a student, random student, and here is create random student, and then in here I want to go and say student invalid student, which is from the random student, and then I'm going to go in here and say invalid student dot user ID equals invalid student user ID, right? And then we're going to write some exceptions. It's going to be very, very, very similar to this guy. So all the way from, let's see, oh, this is in retrieve. I wrote that in a retrieve file. Sorry about that. Let's go into the modify file. There you go. This guy right here. Right, so these are all the cases, and it's going to be very, very similar to this one. I'm just going to copy all that code and just going to pasta that code in here. If you're going to copy pasta, make sure you know what you're doing. Otherwise, it's going to be very embarrassing when people find out that you're copying and pasting code. I guess in this case, it's okay. Right? So user ID, invalid, all that kind of stuff. Right? So let's just go here and say Control RT. And let's see how that works out for us. This guy should technically fail. Why? Because the user ID is not being validated. There you go. So what's it going to say? It's going to say I expected. See, this is 3 tests all in one. 3 different tests. You just did them all in one shot. What are these tests? We're validating 3 things have failed, right? And it's going to show you, like if you hover over, it's going to show you, it'll tell you this expected this to be a student validation exception, but didn't throw anything, just like the rest of them, right? So let's just go in here and add that. In the modify, we had something called validate student on modify, and we're just going to go here and add validate student required data. I think, let's see what this validate student required data does. It's basically pointing out all the required information, right? So it's making sure that the birth date is not invalid, the created by is not invalid, created date, yeah, none of these are the ones that I really care about. I am testing something else. Let's see, validate created signature. Okay, and then validate dates. Yeah, if the date is not recent. So we want something in here to validate the strings, and we don't have that method in here, which is great. So I get to show you what's going on, right? So let's go in here and say a private void, and this is validate student strings. So these are all the string values that we have in our student. And then I'm gonna go in here and say, write a very small method, private static is empty, is invalid. That takes in, it's just a simple method that returns a boolean, is invalid. It takes a string, and it says string is null or white space, and it takes in the value in here. So all of this method is going to do, and someone might say, hey, make the string lowercase. Say no, if I'm using a function out of it, it doesn't make sense that you're extracting your function out of a primitive type, because primitive types should not have functions at all. You know, instead you should represent the alias of it, which is the class level. All right, you have an input, you're passing in the input, and it's giving you that. Let's write a bunch of conditions for that, just a bunch of conditions. So let's go in here and write and say switch based on this student. When that student is an object, so we're assuming that the student is an object, right? In here, and then you want to say when So this is the one case when is invalid, which is student dot a user ID like this. Then we need to throw, I think I need a fat arrow in here. Is that right? Or a, how did we used to do this? I forgot. So it's a when case, yeah, case, forgot case. Case object when this, and then the fat arrow goes here, I think. I'm remembering this correctly. Colon case throw new invalid student exception. I don't know how to spell throw. Let's get that one out. And in here you have the parameter name. Invalid student exception. See why this guy's mad. What am I missing? Invalid case when default blah. We got that. When is invalid. Right, student user ID case. It's probably something really simple. Invalid student exception. Just a moment. Yeah, sure, it wants a final. Okay, cool. We're fine. Throw new invalid student exception. Parameter name is the name of student.userid, and the parameter value is student.userid. So that will give us, so that's one case we're handling. Validate student strings. And because we have a failing test, we could just start taking this guy and putting it validate on modify, which puts in the student in here. Perfect. Let's go back to our tests and let's run our tests again. We have 3 failing tests. Let's run our test against all the user IDs. It should make this work like a charm. We're going to add them one by one until we're done with the entire modify student task. So you see, I bet you thought it's just simple. Oh, just call the storage broker and everything will work. It's not that simple. You want to handle all kinds of exceptions, and you want to have full module that takes care of the validation. So you see, everything here has passed, which is great, which means we can go back to the modify and pick up that test and say that test has passed. Let's see, did I forget to commit the failing one? Get log 1. I forgot to commit the failing one. So, and that's simple. You could just go and say this is fail, and then you can amend this guy. It's great that these things are happening. So you can stage this guy, right? And then you can basically you don't even need to amend. You just say commit, right? And then you go again and you say this pass. It's a good thing that I'm doing it on video, so there's proof that I really wrote the failing test first. So now if I go back here and do clear, get log 2, we have a failing test and a passing test. Yippity doo-dah. Amazing. Let's go on to the next thing. The next thing in the student model is the first name. I'm gonna forgo, this is a new, I'm not gonna validate the middle name and last name because I know there are people in the world that don't have middle names and last names. So we're gonna allow those to be empty intentionally, but we definitely need to figure out the first name. So it's gonna be something very similar to this guy, just I'm copying it. When student first name is invalid and log it async, which is the same thing. This is student first name. Like I said, if you're going to copy pasta, you better know what you're doing. Invalid student first name, like this. This is student first name, and then we want to assign that in here and make sure that this is the first name. And then you want to say this is first name, and everything else should just run. So let's just run this guy and make sure that this guy is failing for all the right reasons. There you go. Because there's no validation for this guy. And let's remember to actually commit this time. So this is a fail, commit, right? And then let's go in here. Actually, I have dirty code in here. Just this guy is not good. Let's just do amend to the previous commit. So that little change, I just added it to the previous commit. You don't have to have a new commit and talk about it for an hour. And then the last thing we want to do here is just want to make it pass. So let's just go to the function, and then let's go to validate student and modify. And in my rules here, I'm just going to add another rule that says validate that this student is first name is not null or empty, like this. First name, first name. Invalid student exception, right? And I don't really like calling it invalid student input. It's actually just invalid student, right? So let's just take that out. And let's call this invalid student. Here's your parameter name, his parameter value, and all the things that you need. All right, so this is invalid student. Now let's go back and run our tests. Let's go back and see if our test on modify would work out. So let's just go in here and run all of this. It's invalid student exception. It should just say the entity name and then say invalid entity exception. So run this guy and it's passing. So now we can go back and say this is a passing test for the student property. So this is pass. Great, fantastic. What else do we need to fix? What else do we need to validate? There's still a lot of stuff that we need to validate, so don't get excited yet. Let's go in here and say, okay, in my student model, I'm gonna allow middle name and last name to be null, but we were not gonna allow the identity number to be null or empty or white space. We're not gonna allow that. It can't happen. So let's go back to our test here, just pick up another test. And let's go in here and say something very similar to that. And then when student, let me make this first name with N capital just so I can sleep at night. Okay, and then this guy in here will be when student identifier number is invalid and log it async, right? Invalid student identifier. And that's that, and then this is identity number, sorry. Identity number, student identity number, like this. And here is invalid student identity number. And here we go, identity number. And here, identity number. Okay, identity number is failing and everything else is the same. Wonderful. Let's run this test and let's see how things work out for us. All right, so it's failing. So let's commit a failing test. Fail. And let's go and make that test pass. So let's go in here and say modify student async. And let's go back into our modification. See, test failing, fix it, make it pass, and so on and so forth. That's test-driven development. That is test-driven development. So you want to do this, and then you want to go here and say identity number, an identity number, and another identity number. And because in the system, in the model itself, the identity number comes before first name, I'm just gonna honor that, so it's not confusing to people. It'll be like, what the heck is going on here? We don't understand, you know, what's going on here. We want to make sure that when I look at things in order, if your model has some 20 properties, it doesn't make sense that you shuffle them around like that. There's no intelligence there. So you want to make sure that in your student model, you're validating them in order. So we validate the ID, user ID, identity number, and then first name. That's exactly how we're going to validate them. User ID, identity number, and then first name. All right, so let's go back to our business, to our service here, and let's just run that stuff, and let's hope these things will pass. There you go. There you go. Perfect. It passed. So if I go back to validation modify, I can copy this guy, and I know because there are no changes in here, I know that I committed that guy. I can go here and say this guy is pass. Boom. Perfect. What's the next thing in the student model that we want to care about? Let's go look again at the student model and see what we got. First name, last name. Okay, so all the strings that we have in here, and I don't know why these guys are red. Let's see why these guys are failing. They should be green, all of them. They should be green. I appreciate these little features in Visual Studio because they tell you if something is not right, but sometimes things fail. Let's run this guy. Let's see what's going on. These are all the unit tests. Yeah, I think we're good. I think this is just a... Oh, it's the acceptance test. We'll come back to this one in a second. All right, the acceptance test is a different story. All right. All right, so it's not a test that we've written, basically. All right, so the next thing we want to validate in the student world, we want to make sure that this birth date, this one is a little tricky, right? Because what's the birth date? You know, what's the limitation? For the time being, we'll just make sure that the birth date is not the default birth date, which is, I think, 1/1, year 1, something like that. We could validate that real quick if we go and say new date time offset like this. It should print out something for us, something or other. Yeah, 1/1, year 1. It just means that this guy, it's the equivalent of null, right? It's the equivalent of null. You know, we want to make sure that this is not the case in here. But other than that, I don't think we probably, as a team, we need to think about what's the age range and maybe pull in some configurations and say, although that, quite honestly, I don't think for high school, I don't know if there is an age limitation there. Like it could be 150 years old and you could still go back to high school and get a degree. So I don't know if we should care much about that. You know, it's not something that I would worry about at the moment, but maybe down the road. So let's write a test for that. Let's go in here and say, here is a test. Fact, we're going to build that from scratch, right? Public async task should throw validation exception on modify if student date, birth date is invalid, and log it async. You could say if or when, whatever the case you want it to be. All right, great. So given, when, then, great. Here's a student, and our student is random student. Create random student. And here is an invalid student from the random student. So someone might tell me, why do you have to fail it? Just put well, other validations will fail. So you want to make sure other validations don't fail, right? So invalid student dot date of birth, birth date equal new date time offset. So this is invalid basically. Some people say default, but it'll be confusing a little bit for people. So we want to be careful with that. Right, so this is primitive dates, and then I'm pretty sure the rest of the validation will be very similar to this guy, for instance, right? So we're going to take all this guy in here. Like I said, you could copy pasta, but you just better be careful what you're doing. So in here, this is invalid student exception, but instead of the ID, it's basically the birth date. Oops, like that. And then in here, I think that's pretty much it. So throwing an exception and everything is good and dandy. Let's run this guy. Obviously, this guy's going to fail. Here we go. And this guy failed. And this guy failed basically because it expected a validation to happen, but it didn't throw anything. So let's commit this guy. Commit fail. All right, so this is a commit fail. And then let's go ahead and basically do make it pass. So let's go in here, modify student async, and validate student on modify. And I think there's a pretty good function that Raw wrote for us in here. Validate dates. His birthday, there it is. Validate student required data. Right, required data. Okay, I mean, kind of generic, but okay. This is created by ID. Okay, we probably want to, yeah, let's break this into validate student dates. That would be much better. And then let's build another one. Validate student IDs. There isn't one already. And this one will just do exactly the same thing as this guy. The only difference is that birth date goes out. Created by stays. Updated date. Yeah, created by, updated by. Something like that would do the trick, definitely. And I think that should be okay. I think that should be okay. So validate student IDs amongst them the created by, updated by. And instead of saying default and stuff like that, we could just go in here and say is invalid, but it takes a GUID, and then say if the input equals default, then that's definitely one way to go. And then you want to replace that with invalid. So you want to say when it's invalid. It'd be much better than. So it's invalid. There you go. So this is much better, right? So I don't have to worry about why it's invalid. It's just it's invalid, and I throw an exception. If I want to know why it's invalid, let's go into lower details and talk about why it's invalid, right? Now, I think we need to reference this guy so we don't break Virl stuff on create. So you have dates. Probably want to validate this guy as well. So pass in the student to it. Should be fine. All right, let's hope that didn't break anything. That's the beauty of unit tests, right? You get to change code around and only the one you care about will fail. So let's just run this guy. I expect only two would be failing, one of which is the acceptance. Yeah, there you go. This is the one that I wrote. Should validate if birth date is not a fantastic, beautiful. So in that case, since this is going to be validating the birth date and the created date and updated date, it's probably cool if we validate all of them, right? So I'm gonna write a test for all of them because as soon as I say validate all dates, it's just gonna validate all of them at once. So let's do two methods in here. One of them is going to be the created date, and one of them will be the updated date. Someone might ask me, say, why don't you just let it to the database since you're going to be validating the created date and updated date match now and they're behind it. I say this is going to happen, down the stream from, first of all, on modify, you're not going to really compare created date to now. It's just not going to happen. You're going to make sure that created date matches what's in storage. But before I actually make the effort and go get an element from storage, if they, like when you're validating, there are three different levels of validation. There's structural, there's logical, and there's dependency validations, right? The structural validation is when you say the string doesn't make sense, like the string is a name but I see 1 2 3 4, right? Unless you're a big fan of wrestling and you like 1 2 3 Kid back from the 90s, then the name doesn't make sense, right? So a normal person name or a regular person name doesn't have numbers in it. So that's a logical validation. But there is structural validation. The structural validation says it can't be null, right? The string structurally is bad. But then there's dependency validation when you say this name doesn't match a name in the database and therefore it's bad. So you see the three different levels of validations. And what I've been doing so far, it's just structural. I'm just looking at the structure and I'm saying, okay, this doesn't make sense. It's kind of a mix between structural and logical because we're going and saying, it can't be default, it can't be empty or null or white space. So kind of empty, empty space might be kind of logical. Maybe I like to think of it as structural, but to each their own, right? So I want you to pay attention to the layers of validations that we're talking about in here when you're looking at every property in every model that you're trying to validate, right? If you want to really build resilient software, this is the way. It's not just, hey, just write some code and just run with it. It doesn't work like that. All right, so we have updated date, created date. The one thing that we want to do here is just want to make sure that this will be for created date. And this will put created date in here, created date, and then here this one will be updated date, updated date, updated date. That's everything, I think. Created date, updated date, log it async. Great. So now if we run everything, we should have we should have 3 failing tests. 3 failing tests. Let's run this guy real quick. Here's 3 failing tests. Each one of them says I expected a student validation exception, but I received nothing. So let's go back to our business logic and make all of these tests fail. So pass. So while we're writing these tests, let's just write all of them. So this guy fail, and this guy also fails. And I think we can amend that failure to the previous. What did I do in here? I just broke things apart. Okay. So I can amend that to the previous commit because I think the previous commit already had the get log 1. I think it already had that stuff in it, so that's pretty cool. All right, I think. Okay, perfect. So we have all of these. And now let's make it pass. Let's make this guy pass. So let's go into our business logic, our function. Let's go into validate student on modify. And let's just call this validate student dates. So we want to make sure our dates actually make sense. We want to make sure our dates make sense. Okay, cool. So let's go back to our tests. And let's run our tests again. It's a good habit to run everything, especially if it takes 213 milliseconds. It's not really that much, there you go. So this guy passed. I don't know why I didn't kick off this guy. Let's kick off this guy as well. There you go. Everything is running and everything is happy. So basically we validated everything. Literally everything. All right, but this is all structural validations, right? This is all structural validations. We didn't get to the real stuff yet. We didn't get to the dependency validations yet. We'll get back to that in a second. So let's just commit that these tests have passed, these last 3 tests that we've written. So that is this guy, pass, this guy pass, and then this guy pass. Commit all. Yes. Boom. It looks like we have a problem in here. Oops. Updated date. Yeah, let's just amend that. Right, so this is student updated date, student created date. Let's just double check updated date, and created date, created date. Great. Beautiful. So we have validating structural. Is there anything else we need to care about? I don't know. Let's take a look at our service. And here's the student model. So we did the birthday, gender. It's an enum. There's nothing you could do there. Someone might say we should validate the name and see if the name matches the gender. No. Just no. There's created date, updated date, and then created by and updated by. So these 2 things we haven't validated yet, right? We want to make sure that created by and updated by are not invalid. So let's go ahead and write more tests. One for created by and one for updated by. Right? Exactly the same as this one. Like this. And since we know these two are also in the same method, so let's just do that. So we created date is invalid. Student if created by is invalid, and in here it would be updated by. Updated by basically the reference. We're making sure the reference makes sense. Right, created by, updated by, and let's go here, say created by, and I'm going to add something in here, GUID invalid ID. So that's GUID.empty. That's this guy. Invalid ID. And I want to make sure that I'm throwing the right exceptions. So this is that. And in the same thing in here, I want to say updated by, and this is an invalid ID. Like this. And then some people will say, why don't you aggregate all of these things and do cases and stuff like that? I'm like, okay, great. You can do it this way. I like to keep things simple. I am a simple person, and I like to keep things simple. This is updated by and updated by. This is created by, updated by. So both of these tests should fail right now. So let's just go ahead and make these tests fail. We should have failing tests. There they are. Is it this guy right here? Unless I already done that. Let's look at our student service validations. Validate student on modify, validate student ID. I did not. So did I assign the right stuff? Created by is an invalid ID. Updated by is an invalid ID. Why these guys are passing? That's not good. So unless we actually have done that. Validate student on modify. Validate student, which is this guy. Validate student ID. F11. Nope, not F11. Yeah. One sec. F12. Yep, this validate just the one ID strings. And then dates. Did I forget to, yeah, I forgot to take away the created by and updated by, and that's why it was giving me a hard time. Perfect. So this is that. So now let's go back and run our test. Okay, perfect. Let's run this guy. We should have 2 failing tests at this point. So this is this guy. Updated by is invalid, and created by is also failing. So we have those 2 failing tests. Let's go and commit those as failing. Fail. And we should also go in here and commit those as fail. So it's 2 failing tests. Commit. So that's great. Now let's make that pass. It's going to be very easy. Go to the validation. Validate students on modify. Validate student IDs. Let's pass a student in here. And then if we go back to our tests, it should basically pass. So let's run our tests again. And everything is passing. Fantastic. So all of this is passing, all of this is passing. It's all good. It's all good. Fantastic. Okay. We have everything passing. All right, so let's go and take the names of these tests. So this is pass, and this one is pass. I don't know if I named the other one fail. Let's look at that previous commit just to make sure that our stuff here makes sense. And console get log 1, get log 2. We should have fail, and yeah, no, I did the right thing. Good, good. Tapping myself on the back. Good job. All right, perfect. So what else do we want to validate? The last thing we want to validate here is two things. First of all, you can't modify the, actually before that, excuse me, before that, if we pull a student from, if we try to select a student by their ID and they return null, we should throw a student not found exception. So let's write a test about that. This one is a little bit different, right? This one is a little bit different. We're gonna go in here and say fact public async task should throw validation exception on modify if student is not found and log it async. So we're going to create a student, but when we go pull that student from database, it's going to say, I don't know about this student. It doesn't exist. This student that you're trying to modify, I don't have it. So let's go in here and say given when then, and let's go in here and say here's a random student, right? And this is create a random student. Should we validate? No, hold on a second. There's probably more to validate here. We want to make sure, not the created date, from a structural standpoint. We want to make sure that the updated date is within 1 minute before or after now. Within 1 minute. So this here is an interesting case. Why? Because we want to create a random number and then get that random number and hit the updated date, add these random minutes, and then validate and see if that method, if that updated date, if it's before, it's more than a minute before or after now, we should throw validation exception before we do this one. So let's do this. We need a theory. And in that theory, we want to say member data name of invalid dates, I think, something like that. There's a method in here that Viral built for us. It'll give you random minutes more than 1 minute from now. Random minutes yeah, we could say random minutes from now. Let's just say random more than minute from now. And this is random more than minute after now, or something like that. A minute before now. Something like that. That's a better name. And this get minutes for validation of date. Invalid minute cases. Right, something like that. All right, so invalid minute cases, I could go in here and go to my modify and just put that method name in here. And now I have a bunch of minutes coming in. So integer invalid more than random more than 1 minute. I think I'm at 126. Let's do that. Okay, so I want to validate, and this one is now you're doing something interesting, right? You're saying if whatever is passed in has an updated date is before or after now, right? On the updated date, more than a minute, then throw up, just throw an exception, say this is not a good date, right? Which means something. It means that we need to create the random student with the current date time and then add on top of that. In that case, we want to go here and say date time offset. This is random date and get random date time. This is random date time. And in here, we're going to do something interesting. We want to set up our datetime broker mock, setup broker.get current time, and this guy returns a random date time, and wherever that random date time is, we're gonna pass it in here because that's what we believe is the current date time, right? So we want to go here and say we're gonna say dates random time. But with that being said, we're gonna push that to the future or pull it to the past. So we know for a fact that whatever is now, we're pulling it behind or forward a minute or so. So we're gonna go in here and say student invalid student equal random student. And this invalid student basically dot updated date equals itself invalid student dot updated date, add minutes, and this is random more or less than 1 minute. You see what I did there? I'm basically saying whatever the date that you assigned is that you believe to be the current date, move it more than 1 minute ahead or 1 minute behind, so we throw the exception and say this is an invalid date. So when that happens, then we have expectations, right? Expectations that are invalid student exception equal new invalid student exception. Oops, sorry. This is name of student dot updated date. So this is the guy, and then parameter value, right? Student dot updated date. Sorry, invalid student dot updated date. And then in here we want to say expected student validation exception, and just like the usual student validation exception, and you're passing an invalid student exception like this, and then you want to go and say, see, before I even called my dependencies, right? And the rest is just like any others, right? The rest is just exactly the same. Validate. There's one little difference though. In here, we're actually gonna call the date time before we log. So in here, this, see, I told you if you're gonna do copy pasta, you better know what you're doing. You know, I don't mind it as long as you know what you're doing. Broker get current date time must have been called once. Okay, so date time is called once. There's a validation exception. Here we go. All right, okay, so I have all of that. That's all fantastic. Now, let's go ahead and make that guy fail. This guy has to fail. Let's make it fail. And this guy is failing, which is great. Now let's pick up that method. Go here, do a commit, push this guy, say this guy is failing, and now let's go make this actually pass. Right? How do we make this pass? Go to modify student async, go to validate student. Oops, go validate student on modify. And then there will be a method in here that say is date not recent. Is date not recent, and this guy takes in the student for validate dates, and it does that little trick in here. Let's change this to say validate created date is recent. And let's have another one very similar to this that says validate updated date is recent, and this will be my updated date. Right? And we want to put that guy in here. So in here we're actually saying, so what am I doing with this recent? It's calling is date not recent. What it's doing is that it's pulling the date from the date time, valid minute variation, and it's saying subtract difference. And then it's saying, you know, this is now, subtract the date time, and see the difference. And if the difference is more than 1 minute, you know, let's do that. And I think it's easier to call this just 1 minute. So we're saying If the difference, whatever it's minus or plus, if it's more than 1 minute in any direction. I also want to basically make this equal bigger than or yeah, bigger than. This is good. This is good. All right, so let's go back to our test here. And let's see if our test will pass. So in here, I'm just going to run my tests. Looks like we have a passing test right here. So this way we validated that the updated date, which is what we care about. Someone might say, what about the created date? I said the created date could in the past, something that we have posted or we're testing on modify, right? So should throw validation exception on modify if student is not found. Sorry, this is if student is not found. No, I forgot. Yeah, if student date, updated date is not recent and log it async. Am I still within 120? I think so. So this is the guy, and this guy will be passing. Right, so there's our guy. Okay. All right. What else do we want to test? We want to make sure that the created date and the updated date are not the same. When you're modifying dates, the expectation is that your created date and updated date on modify should be different. They have to be different. Therefore, we're going to write another test in here, and we're going to play a little bit with the dates, right? Even though on modify, we're going to make sure that the date is recent. We're going to move the created date outside of that realm and see what happens, right? We could go in here and say fact public async task should throw validation exception on modify if created and updated dates are the same, and log it async. Okay, what does that mean? It means that if I have a random student like this, student create random student, and that might break a lot of tests. I'll show you in a second. It might be disastrous because basically, you know, on modify, when you're creating a student, right, and if it hits that condition, it's going to be a big disaster because that means we have to go back to our test and make sure that these two are different. We'll see. We'll see. Because of the sequence of how we're building this, they're actually maintaining that structure. So I don't think it's going to be a big deal. I don't think. So this is a random student in here, and we want to before we even call our dependency, this test actually should come before even calling the dependency. So I'm not even going to do the date time thing. I'm just going to say, you know, this is the same date. They're basically both have the same date. Student, invalid student. Because I can't show this, I'm going to say with same created and updated dates. I can't show it, right? Or even better, let's say invalid student is this random student. I'm just going to go here and say date time offset same date equal random student dot created date. So I'm going to go here and say invalid student dot created date is same date. Invalid student dot updated date equals same date as well. So both of them have the same date. Although that they are, but my test is not telling me that. I want to make this verbal. I'm trying to make this verbal, right? All right, let's go in here and say, okay, same date. So what do I expect? I expect that it throws an exception on the created date. It says the created date is invalid, right? So I'm going to go here and say invalid invalid student exception equal new invalid student exception. You could go as verbose as you want, but for this one, we're just gonna go like that. So name of, so this will be student dot created date, and then here will be, you know, parameter value, student, sorry, invalid student dot created date. So we're gonna blame it on the created date, right? And the rest is gonna be very similar. You can take it all the way from here. Actually, not even this guy. We're not even gonna call the datetime broker. So you can take it all the way from here, all the way down, and you're gonna be absolutely correct. Copy pasta, just know what you're doing. Here you go. All right, perfect. So let's run this guy, and this guy should fail. And this guy should basically say, yeah, I expected the logging broker to be called once, but it was never called. Wonderful. So let's go here and let's say this failed. And let's go fix that. Because of the order of things, I'm going to keep that guy to come before even calling any dependency. So let's keep it in here. There you go. Created date, updated date, perfect. Let's go into modify student. And let's go into validate student on modify. And then before this guy, I'm going to say validate dates are not same. Right? And I'm going to go here and I'm going to say students. And I'm going to build that method in here. I'm going to go here and say private void validate dates are not same. And here's my student. And because this is just the one case, it doesn't really need a switch. I'm just going to go and say if student.created date equal student.updated date, throw new invalid student exception, parameter name of student dot created date, parameter value student dot created date. So there you go. So this guy, validate dates are not the same. This happens before we even validate updated date is recent. So that should make our test pass, should make our test happy. Let's see. Let's go back here, control minus, control RT, moment of truth. And this test is passing. Wonderful. So let's push this guy in. All right, what's the next step? The next step is that we want to validate that when the database returns a null, that we throw a null student exception. If you're trying to update a student that's not in the database, it doesn't make sense. It doesn't make sense, right? So we want to make sure that if that's the case, we want to throw the right exception. So what's the test that we're going to type in here? Fact public async task should throw validation exception on modify if student doesn't exist, and log it async. All right, so everything is going to be fine except that the student is going to be a little wacky. The student's going to be a little wacky. So what are we going to do about that? It's really simple. Let's create a random date time to surpass the date validation, structural validation. Now you're running into dependency validation. See, now you moved from structural, logical, now you're going into dependency, which is the last kind of validation that we're going to be working on. Sometimes they mix together. Sometimes the structural and logical are mixed together, so you want to pay attention to that one. Random date time, and then here and say get random date time. And here is a student, random student, create random student. And then in here, I'm going to say student.invalid student, right? This is an invalid student, and it takes from random student. I'm just going to make sure, just to surpass the validation, that actually I'm going to call this non-existent student. Non-existent student. Right? This is non-existent student. All right. And then I'm going to go here and say this non-existent student dot updated date matches that random date time that I created. Why? Because that updated date it will be matched with now. We already agreed on that. Right? So let's go set up this guy. So this is the date time broker setup. Broker date current date time, and this guy returns a random date time. So we covered this case. Fantastic. And then what we want to do, we want to go here and say this student doesn't exist, right? So we want to go and say student storage, this is no student, equal null. So there's no storage students, no student, right? Let's put that guy on top. We'll come back to this guy. Well, let's keep it here, it doesn't matter. So this dot storage broker mock dot setup broker dot select student by ID async, and I'm throwing in there the non-existent student dot ID returns async no student. See what I did there? So I'm basically saying that when I go search for that student, if it exists in the database, it doesn't exist. It's a problem. It doesn't exist. So what are we going to do about that? It means that if that's the case, it means that we have a not found student exception. Hopefully someone already did that for us. New not found student. Yay, there it is. And then we're passing in the student ID. So non-existent student.id. And then inside that guy, we say expected student validation exception equals new student validation exception, where we pass in not found student exception like that. Let's see why this guy is complaining. It's not. I'm just too fast. All right. Perfect. The rest of everything is the same, like everything. The only difference here, you want to make sure that you actually called this and you called this. It's going to be the same thing as this guy. The difference here is that, and we want to make sure that this is happening in the right chronological order. So this is non-existent student. And you want to make sure that, okay, you're calling the datetime broker because you're doing your validation, but in here you're doing storage broker. The error happened after the storage broker. So you want to verify broker dot select student by ID async non-existent student dot ID was called once. All right. So, okay, there's that stuff. Called once. All of this is good and dandy. It's a validation exception. It's all good. All right, let's go and run this guy, and let's make sure that this guy fails. There's multiple issues that we're going to run into. I'm going to show you in a second. All right, this guy's failing. Why is this guy failing? Because it's saying I expected this to happen, but nothing was thrown. Student validation exception. I didn't receive any validation exceptions out of this operation that you just made. Let's just put that in there. Let's say this guy failed, and then let's go and handle that situation. How are we going to do that? Because we had a storage student, let's call this guy something even more interesting, like maybe student. Why maybe student? Maybe it's there and maybe it's not, right? And then in here, we're going to say validate student storage student, right? So this is maybe student. and this is student.id. What this guy is going to do basically is that it's gonna go in here and say if the storage student is null, then throw not found student exception and throw that exception and move on with your day. Right? So let's go back here and let's run our tests. Let's see if our test actually does what we expect it to do. Here we go. So we have a passing. So if the student is not in the database, we're going to throw a not found student exception. Perfect. Now, the next step in our validations is that we want to be handling, we want to handle the situation where I don't think we need this guy anymore because we already are calling that internally. So this guy goes out. And then the next thing we want to do here is that we want to validate we want to validate against storage student on modify. We want to validate against student storage on modify, meaning that the created by should never change. Two conditions. Created by should never change, and the updated by should always be ahead of the storage updated by. So the updated by, the current student updated by, should always be behind what we're passing in, right? So let's just, before we do that, let's just run everything and make sure that everything is running, because this is kind of, we're getting to the end of it. We're getting to the end of it. It's been 2 hours, so I hope that people are learning from this, and I hope they're either laughing at me or learning from me, and both cases are fine with me. So, okay, there's one failing test should modify student, and this guy is mad, obviously, because in this guy, the input student that we created, now because we have all that validation stuff going on, the problem here is that the student that we're inputting has bad dates, right? So it has random date, which is the current date, and we shouldn't really be doing it this way. And I'm glad it's just this one that's failing. So let's take this guy out, and let's get random time. We already set the random time, and then random days. Let's see. Why did I do random days? Because the updated date before update storage student. Yeah, I think I was thinking a little bit ahead for this one, and we didn't even add that validation yet. So okay, so this is just random dates, right? And we can maybe we need to keep that guy. The one thing we want to modify is just to go here and say input student, right, dot updated date equals random date. And I don't think we need that guy. Yeah, we're right. All right. Let's see if I run this guy, what happens. It should it should be happy. Still not happy. Let's see why it's not happy. The exception that this guy is throwing is, this might be something really simple. Invalid parameter name updated date. This time random date, and that's what we set to current date time. That's the input student, and the input student is what we're passing in. Input student. Okay, what are we passing in to our method? It's this guy. So input student dot updated date should match that. And then the created date. Okay, what did we put on the validation for created date? Dates are not same. Yeah, they're not same. So if they are the same, it'll throw an exception. No, this is good. So validate updated date is recent, which is this guy. this guy will go and say is date not recent, and it will try to run this little stitch in here, which means that if I do debug, let's just see why it's throwing that exception, or whether this is the exception that it's complaining about. Let's just see. So what's the difference here in minutes? So this is the difference. It's 8 hours. Why is it giving me 8 hours? I might be missing a teeny tiny detail. So this guy here is coming in as 7/1/1805. What's the date on this one? 7/9/1805. Oh, I know why. My test is probably adding days, and trying to be smart. There it is. We don't want that guy. That guy was a bad idea. Let's run this guy. There you go. This guy's good. Just a quick modification before we move on, just to make sure everything is passing. So I'm going to put this again as pass. Excuse me. And then let's run everything again. All right, we have everything passing except the acceptance test, which we're going to come and run into and fix real soon. All right, should modify student async. And this guy is good and dandy. All right, so what's the test? What's the next test that we're trying to do? This is for validation modify. We want to make sure that, you know, our student created date is the we want to make sure that input student created date matches the created date in storage. That's one validation. The second validation, we want to make sure that the student updated date is ahead of the storage updated date. And then we want to make sure that created by are the same. And we don't care about the updated by. So about 4 tests. You have patience for 4 tests? Let's go write 4 tests. So it should be something it should be something very similar to our happy path, except that we're going to modify a few things. So let's pick up our happy path test in here. There it is. Modify. Modify is the biggest piece. Every other task is very small, and I'm very happy that I get to do that. So this here should throw validation exception on modify if storage created date is not same as input created date, and log it async. I think we exceeded 100. Yeah, okay, the same is not the same as created date. Does that help? 121. Let's lose one more. If storage created date not same. There you go. So what you love about programming, you could just shorten things up. All right, deep clone. Why this guy doesn't know about deep clone? Do we need a reference? Yes, we do. All right. So here we go. So this is before update storage student. So it's the random student deep clone. And then what we want to do is that we want to make sure that it throws an exception, because first of all, it's not going to get that far to update student async, so we don't care about that. So after update thing, that goes out, right? And all of that portion down here goes out actually. We just want the piece where it's passing. So this is all good. So random days, I don't know what we're using that for in here. We don't. That goes out. And then we're just simplifying things. Random student, this is my input student, and then I cloned it with whatever in storage. The one thing I want to do is that we want to make sure that the input student created date is different. But the created date cannot be too far ahead of now. See, that's the tricky part. right? Sorry, actually it doesn't matter. So I'm gonna go here and say input, watch this, input student dot created date equals before let's call this storage student because we don't have before and after yet. Storage student. So this is created date and then is storage student dot created date dot add, and we want to add any random number, doesn't matter, right? So add minutes. We could actually use this for the minutes thing and turn this into a minus. I don't care, you know. Let's just say a random integer random number. Get random number, and then in here we can go and say it's just something that's different than whatever this thing is, right? So in here int random minutes equals random number, which means that add minutes random number in here, it means that the created date in the input is definitely different than what's in storage. Before or after, it doesn't matter, right? Which means that we have two exceptions in here. Invalid student exception. New invalid student exception. Parameter name. Name of student dot created date. Parameter value. Student dot, that would be the input student. Input student dot created date. Okay, so validate this guy, and then the rest is really super similar. So you're gonna take that validation in here, and we're gonna slap that in there, and then let's take that guy in, and then the rest going downwards is we call the storage, the logging, all of that. Yes, all the way from here to here is exactly the same. That's a completely different validation, but yes. So this is input student. Instead of input student, let's call this invalid student because it's invalid. All right, so this updated date, we played with the created date. Here's invalid student ID. We're good. So let's see if that guy fails. It's a little bit of a long test, but it's basically going after a very particular case, and it's very, very precise about it. All right, so this was just my breakpoint to see if the world is good. And here is my exception, and it said I expected an error to happen, but nothing have happened. Wonderful. Let's commit this guy and say this is a failing test. And let's go ahead into our student in here. So this is validate storage student. We're validating storage student. Then in here, validate against storage student on modify. So in here now we want to pass. We know that this guy is not null, right? So this is maybe. So this is my student, and this is maybe student. And I'm going to come back to that in a second. So validate against storage. So we're going to put a bunch of rules in there. And these rules is really what's going to govern all the tests that we're going to be writing onwards. So this is the created date. So let's go in here and say, in the validation, we need a little test. Let's put it in here. Public void validate, and here is student. This is storage student. Let's say input student and student storage student. All right, and we're gonna have a bunch of cases, right? We're gonna work with a bunch of cases in here, and we're gonna take care of each and every one of them, right? So let's just start working with that. We know that both of these are valid students, right? So let's go and just switch on the input student. And let's just start typing some things. When, so this guy here, when input student, come on, you can do it. Switch student, what am I? Case. When input student dot created date does not equal storage student dot created date. That's a problem, right? And with that problem, we want to throw a created date exception like this. So here's one case. And that should take care of that test that we have. Let's see if that's true. If I run like this, there you go. So that test passes. Why? Because it threw the exception when the exception is due. Pass. Let's get the others. Should throw validation exception on modify if storage created date. Let's copy the same guy. If the created by now is different, see, now we're doing something else. If on modify of storage created by, because you're not supposed to be changing history, right? Same as created by and log it async. Oops, what did I do? Like this. So in that case, things are going to be different. Instead of this guy, I'm going to say different id GUID.newGUID, right? And I'm going to go here and say created by equal different id, right? So that means in the created by in here, in my invalid student, created by will be an invalid created by, like this. Invalid created by, which means that all of this changes like this and everything else stays the same. Let's run this guy and see what happens. Control RT. And this guy is failing for all the good reasons in the world. It's fail. Let's make sure it's failing right. Here you go. Fail. Expected an error. Didn't happen. And then let's go back to our validations in here and let's go and say here's another case. It's literally almost exactly the same case. They're just rules. We're just putting rules, right? Just go in here and say when that input student dot created by is not the same as storage student as created by. If I run this test again, what happens? Should go green. Green, green, green. Or not. Let's see why this failed. Invocation, expected a logging error created by invalid student. Invalid created by. It's definitely different than what's in storage. Did I? Oh, let's see. This is validation. Validate against storage student. Okay, this guy received no exceptions. Let's see why. Invalid student. Let's go here. We might have missed something really tiny. Created by. We're passing in this created by guy and storage student. It's definitely gonna be the same as this one. Let's see. Let's put a breakpoint in here and see if we got that far. Let's see that. Control debug. Did we even get that far? Okay. So the created by on the input is C3A, while the created by on this guy is this. So this is invalid. It's saying created date instead of created by. That's my bad. That's why these unit tests are very important. Now this guy should be passing. Wonderful. So it's this guy, and this guy is a pass. All right, two more. We're probably tired. So we want to validate that the created date is ahead of, sorry, the updated date is ahead of the current updated date. Still within now, but it's ahead than the one in storage, right? So let's go here and copy this guy. And the only there should throw validation exception on modify if storage updated date right was the same as updated date. So these two should not be the same. Should not be the same. The other validations are already done. You know, we already validated that's now and all that kind of stuff. It's great, right? The created is taking care of it. Don't validate backwards. That's a different layer of work, right? So let's put that back in here, and let's just say that the storage created date is different, right? So here's a random date. We're probably just gonna do the same thing that we did with the created date in here. I'm just gonna pull the storage updated date ahead. So it's gonna be whatever the updated date is plus stuff, right? So that makes it not equivalent. So let's just go here and say updated date. And okay, this is a student ID, you got all that. And then you want to go here and say invalid student dot updated date. Oh no, actually I think we're good. I think we're good. Mm, yeah, I think we're good. I think what we want to do, this is the one time we're actually gonna use this. So when you're creating dates, you're passing in that. So the created and updated date are the same, right, in both situations, and that should throw an exception basically. And the blame would be on the updated date, of course. Updated date, updated date. So now, even though it's recent, it's similar to the one in storage, and because it's similar to the one in storage, it should throw an exception. It should say the world's on fire. Let's see, Control RT. So the updated date of the incoming should always be ahead, should never be the same, right? And don't worry about the ahead part because we know that it's already validated against time. So okay, so this guy failed. It should probably say I didn't throw anything. Yeah, perfect. So let's just go here and say commit this guy fail. And then in here, validate against storage on modify. We're going to add one more rule that says created by updated by in storage. Updated date in storage is the same as updated by in the input. So if these guys are the same, something is wrong. That's all we're going to care about here. So let's run this guy. This guy should blow up. Blow up, blow up, blow up. Actually, it should pass. I don't know why it blew up. So updated date and create an updated date and both are the same because okay, let's see, invocation once but found blah blah. Something else might be blocking this validation from even happening, and it's very likely because I bet it's the created date. Yeah, the created date in storage. Yeah, the created date in storage is very similar, right? So it just add, okay, let's just add a bunch of int random minutes, right? And then let's say get random number. right? And or maybe get even negative, right? Get negative random number, and then minutes in the past, right? This is random minutes, negative minutes like this. And we want to just make sure that both storage, so in the invalid created by, okay, we want to take this guy out. We shouldn't be using that guy anymore. And I hope we're not. We are not. Perfect. And what we want to do here is that for that invalid student, before we clone, or random student before we clone, we want to go and say random student dot created date equal random student dot created date dot add minutes, and just, you know, throw some minutes in the past. Minutes in the past. This will definitely have our stuff failing. Sorry, passing, because now, because we had validation in the past that says created data of database should not be the same, and now we fixed it, right? Okay, so this guy here is a pass, clear pass. Now, what else do we want to validate? I think that's pretty much it. We validated everything that you can think about. The last thing we want to do, we want to make sure we handle the exceptions that are out of our control. So you will see in here, I'm going to create a new file. So these were exceptions that we create to indicate particular cases. Now, let's go and take care of the exceptions that come out of the database or the system, something that's out of our control, right? So I'm going to clean up all. Actually, we might actually leverage this. All we have to do is just, let's see here. Yeah, this might actually do the trick for us. We just need to take care of the happy path, and everything else should be okay. So let's just clean up all of these, and let's write one from scratch. Let's do that. So it's basically the happy path, or partially the happy path. The only difference is that we're throwing an exception that's coming out of the database. What are the exceptions that come out of the database? There's SQL exception. There is DB update exception. There is a locked exception. That's why we're using this exceptions library, right? And down the road, when we start building relationship, we need to be handling the referential exception. We'll come back to that in a second. All right. So I think retrieve here has this part. No, let's just go to the validation modify, and we have all of these tests, and then I think there's one case in here where we said student not found exception. That's perfect for our case, because that student not found exception, we could just change it to whatever we want that comes out of the database, and then move on with the rest, and everything should be just good and dandy. So let's say not found. There it is. So there it is. That's a good one. So if I go in the exceptions area in here, I could go and say fact public async task should throw validation exception on modify if SQL. So now it's not throwing validation, should throw dependency exception on modify if SQL exception occurs, and log it async. So you're making an interaction with the database, and something horrible and terrible happened with the database. We want to take care of that. So in here, we basically are saying this guy is returning no student. Instead of doing that, we're just going to do something else. Instead of this in here, we're going to say var SQL exception equal get SQL exception like that, right? And it doesn't seem like anyone handled that. So let's just go and pull that up from my school aim. I think I had that in there. We could just pull that. There's a special trick to taking care of SQL exceptions. We could just copy that real quick. Test. Do I have SQL exception in here? There it is. Get SQL exception. Let's take this guy in. And here's a test. And let's just throw this guy right here. Oh, there's one in here that's just called create. This should be get SQL exception because it says get uninitialized object. So we should probably call it get SQL exception. Okay, just a little mismatch. Okay, so this is this guy, and we don't want the no student. I think we're good with that. And what we're basically throwing is that SQL exception right here. So when the database fails to when you fail to communicate with the database, completely failure to communicate with the database, you should be able to handle that. So this is throws async, and it throws this SQL exception. So your database throws a SQL exception on update, and then you're working with the rest. This should be student dependency exception. This is expected student dependency exception. Expected student dependency exception. This is student dependency. We expect it to throw a dependency exception right here. And then everything else should be good and dandy. This test will pass right away because we're using the try catch that the add is using because they're both returning the same thing. So technically, this test will be green immediately. And we're going to follow up on the rest of them really, really quick. There will be one of them that we need to take care of. Let's just see if this guy passes. It didn't. Let's see why it didn't pass. It might be a validation thing. Dependency. Okay, what's the error that came out? So this is dependency, student dependency, modify, non-existent student ID. We should just call it some student because we don't care actually what it's doing. Some student. This is just a part of sorry, this guy in here. Some student. We say some student when it's just something that we're adding in just to make sure that things are moving forward. So this is that part. And some student has updated date that matches now. Fantabulous. And why this guy is failing? Let's see. Oh, we're supposed to log critical because this is a copy pasta. Unless you know what you're doing. We log critical because this is infrastructure issue. If you can't communicate with the SQL, then no other operation will be able to communicate with SQL, and therefore that's critical because it's blocking everything and everybody, right? Let's put some light in here. It's getting a little darker. There you go. All right, and this guy passed. Wonderful. So let's just put this guy. These are already all handled automatically with the try catch. So this is passed. We just want to make sure that we are actually handling them in this particular case in the modify. Let's move forward with that. So what else is out there? There is a bunch of exceptions. There's DB update exception that I want to take care of. So DB update exception. Database update exception, which comes in from new database update exception, like that. And it's almost exactly, I think it's DB update. Yikes. DB update exception. There it is. Right, and this database update exception is what goes into the dependency. It's what this guy is throwing, and instead of SQL exception, we're going to say DB update exception occurs on modify. And this guy should pass, should be happy, and should pass. But we don't log critical for DB update though, we say log error. Let's go here and do Control RT. All right. So this passes, and then let's do the next one, which is the next exception that may occur is the lock exception. And that one is not something that we handled yet. The lock is when you're modifying something, and at the same time, while you're modifying, some other process is trying to do the same thing, right? So this is if locked exception occurs on log it async. What is this? Locked exception. Locked exception. I think it's let's see. Exceptions dot models dot exception. This is a custom library that I built. I think it's foreign key invalid column. Oh, when the concurrency exception occurs, right? So this is db update concurrency exception occurs. So this is database update concurrency exception. db update concurrency exception occurs. Something like that. How long is this guy? 116. That's why it fits. See how small the screen is and it can fit. So db update concurrency exception, and this guy still logs an error, but this guy is going to fail because the exception, we wrap that up in another exception, right? I'm going to show you that in a second. This guy passed. Let's see why this guy passed. db update. Oh, because db update exception handles that case, and we want it to actually do something else. So let's just create a new, give me a second. Let's create a new model in here. And let's say student locked student exception. What's locked student exception? It distinguishes between, students that are, when we're trying to, not locked and present or anything. This just means that the student record is locked and you should try again, right? So let's write an exception here. Here's a CTOR, locked student exception. This guy will take in exception as inner exception. And then from the base, locked student record exception, please try again later. And then pass in the inner exception in here. So what we're basically saying is that the database is busy. Other processes are trying to access this guy. And then try again later. And I'm going to show you we're going to use a library also I built. It's called RESTful Sense to handle that kind of, situation. Okay. So let's go and say we are turning this, in our exception, let's go and say we're turning this database update concurrency exception to locked student exception equals new locked student exception, like this. And this guy will take the database update concurrency, because database update concurrency, it's very, very generic and we want something verbose to work with, right? So there's this guy, and then the locked student exception is what we're really passing in, and now this test will be failing. Let's see. And that's probably the last to last, almost the final one that we need to handle here. And then I'm going to build the controller, and while I'm at it, let's see if if anyone did the acceptance test, and we take care of this entire feature end to end. All right, so this guy is failing. It's failing for all the good reasons. Let's go here and do commit, and let's say, oops, what did I do? This guy, fail. And what we're basically going to be doing here is that in the student service validation, there will be an exception that we need to take care of in here, which is catch db update concurrency exception. And we're going to turn that into student locked exception, new student locked exception. Oh, sorry, locked student exception. And this is db update concurrency exception. And then we're gonna basically, that's what we're gonna be passing downstream. So throw, create, and log dependency exception, and that's gonna be our locked student exception. There you go. Locked student exception. Does that make our test pass? I don't know. Let's find out. There you go. We have a passing test. This is locked student exception. Locked student exception. The record is locked and we need to retry. Again, like I said, you're handling all possible scenarios that could happen when you're interacting with the database. And you're forming it in a way that it actually makes it easy to identify what the problem is or what the problem is. Some of that stuff is redundant, I understand, but it's very important for you to do them. The last exception that we want to handle here is basically the service exception. So let's throw a service exception out of something. The service exception is basically just an exception, just some exception that happened that doesn't fall within. So just should throw service. Watch this guy. Should throw service exception on modify if exception occurs. If service exception occurs, and log it async. So instead of db update, I'm just going to say service exception. This is the generic. This is us, the catch-all kind of. So this is exception. And out of this exception, we're passing that guy to this guy, and that's what we're throwing. And this should be expected student service exception. This is the last thing. This is not a dependency, not a logic, not anything. It's just the anything else that could happen in this service, like a catch-all. This is the catch-all for everybody. And this logs error. It's all good and dandy. Guy should just pass. And that would be the last thing. This is the entire modify student sitch end to end. I hope I didn't miss anything. And this guy's pass, right? This guy. Why? Because it's already handled in the try catch block. Here's this guy. And this guy is a pass. All right. Let's go back to our code. Just make sure right click. You want to do a quick right click. You want to do analyze and code cleanup. Everything is cleaned up. So I'm going to do here, say code cleanup. So everything is good. Just a little space you forgot there, or a little hash you forgot here, or whatever the case may be, right? And then in the service, you want to make sure that your service is clean. You're not having additional, say with the return, we take an empty line. Every return has an empty line. But with these guys in here, I want to basically say this is input student, and this is storage student. Are these guys over 120? They're not. I think it looks fine. Control KD. Everything is clean. Another code cleanup, code rub, code cleanup. There you go. And that takes care of the entire service piece. Now, while we're at it, let's do the controller. I don't know if anyone did the controller. I don't think anyone did. So let's do the put student while we're at it. So let's see what we have here. CRUD, create, delete. So this CRUD, this gate goes before that. This takes student ID, CRUD, and then we have update. So HTTP put, right? And this guy will be public async value task action result student update put student async. See, the language here now changed from update to modify to put. It depends on the environment that you're in and what you're doing with that environment. And I guess you're taking in a student. I don't know why people are doing from body and stuff like that. I don't think we need that anymore, but maybe we do. Anyway, most of these exceptions are the same, so I'm just going to copy all of that and just throw it in here. So student validation exception, you're picking that and you're saying already exists. Student, now that's one we don't want to handle, but the one we want to handle is not found student exception. And this guy reports, instead of conflict, you're reporting not found. Right? And because this is a return, you're taking a new line and so on. And also the same thing in here. Any other validation exception that comes in. And then you have this student dependency. We want to handle the locked stuff. Right? Student locked. We want to say try again. So you'll notice in here you get to say locked. And if it's not here, that means we didn't build our controller right. So instead of controller base, you want to say RESTful controller. And if this guy is not available, let's just go and install it. It's a little library that I built that helps you communicate all the codes that don't come natively from the ASP.NET platform, like locked and out of storage and out of memory and all the codes that you may think about, right? So this is RESTful controller. Let's do that. And then in that RESTful controller, we basically see, you see locked here is great, is great. It's there. So this is where we say when student dependency exception dot inner exception is locked student exception. When that's the case, you want to get the inner message, right? And this inner message will basically tell you what happened. And then you're going to pass that inner message in here, right? And student dependency exception. I think that should cover everything. So student validation in general, there's not found student exception, then all the other validations. You're only doing when there is a different code that you want to communicate. Like in here, I'm doing when on dependency when locked student exception, because locked in here, if you go into the definition, it will communicate something completely different than what you think the case may be. It's like, I think 423 or something like that, right? So it's locked resource, right? And while we're at it, let's just do our due diligence in here and say public static string get inner message of an exception, just to make sure things clean. And what this guy is doing is saying exception.inner exception.message. So it's returning that little thing. And then we could replace all of that junk in here with something more meaningful. So this guy here goes like this. Anywhere we said get inner message, we should just clean that up. Like this, and maybe this one as well. Get inner message. So all of this is good. Let's clean it for the others as well while we're at it. You know, want to do your due diligence? Let's do it all the way. I think it's pretty much student validation exception in here. So let's go and say get inner message student validation. Whatever it says student validation, we should be covering the inner stuff. This is also another student validation. Here's a new line. We want to do the same thing in here. We want to do the same thing in here. Yeah, whatever you see that inner. Yeah, and whoever did that get student delete student by ID, we still need to go back and fix that. So that's my fault. I approved that and it didn't have all the stuff that we need. Okay. Student validation, it looks like we're good. That means if I search anywhere for inner exception dot message, it should only be in one place. Yep. A message like this. Yeah, perfect. Perfect. All right. So this is all good and dandy, but that's not good enough until we test it out. So let's test stuff out. This is add put student controller. Commit, save. All right. Now, before we commit that stuff, we want to run our application and make sure things actually work, right? So this is hello Mario, the princess is in a different castle, yay. And then let's go here and do that. Get. And let's see. So this is /API/students. I don't know if I have any students in the database. I don't think anyone implemented the implemented the get all. I'm gonna have to go back and add that. But okay, we have this guy. Let's create a student. Let's create a little student. There's a nice script that you could use. Let me see if I have this script in here. This script in here will give you the current date time. So when you're updating something, when you're creating something, and then you're updating something, it's so easy to go and say, oh yeah, it's the current date time and all that kind of stuff. So it's just there's also like if you look at this student model in here, and you want to JSONify that stuff, right? You can go in here and pick up this guy and go to this simple website and say C# to JSON. I'll just create an object for me that I could work with like that. C# JSON. Yeah, it's looking for IAuditable, which is not defined. And then let's do JSON. The type or namespace. What else do I have in here that might have dependency? Gender, right? So I could go here and say public enum gender, unknown, female, male, unknown, whatever the case may be, right? So let's do JSON. Here's a JSON, and now I can steal that guy, and I can go here into my Postman. I can throw that guy, and now for created date and updated date, we can throw any IDs in here, but for created date and updated date specifically, you want to go here and say something like this. See that mustache templating thing? And then in here, if I go and say, let me copy this guy in here. So from your scripts, and then in here, I'm just adding this script, and I'm using this timestamp situation. So I'm just going to add that in here, and the same thing will happen with this guy. Right? Now, other than that, obviously, if I do a post like this, obviously I'm going to get validation exceptions and stuff like that. API/students. Am I calling the right thing? Let's see. I hope I'm calling the right thing. Technically, if we call home with a get, should say hello Mario. So we're calling the right thing. Now it's just /API/students, and we're doing a post because I need to persist that student in the database. It's not found. Let's see what's wrong with our controller. There might be something funny that we could laugh about in our controller. Oh, so the controller says student instead of students. That's wrong. So let's go here and say rename, like the standard RESTful operations, This should be students like that. You say / plural singular plural singular. That's one thing that's funny. And then let's go here. So this is a student service, and we have the dependency and all that. Fantabulous. So let's go here and get Postman, and now we should get a validation exception because some of our stuff is not right. Post. Is there anything else? Students, RESTful controller. My application is not running actually. Let's go run that again. With auto migrations on, we should be good. And my API is dying. Let's see why the API is dying. Let's investigate. All right, that's that. And then API/student. If I do a get, it should say not found or something. Yeah, the request multiple endpoints matches. Multiple endpoints. That means something here is wacky with the definition. Post get student ID. HTTP get, HTTP delete. This is all good. Why is it complaining? Do we have two controllers in here or something? Post student async. Students controller, RESTful controller. And this is a get. Let's generate some random student ID. Let's just see if this guy actually is doing anything at all. So this is the RESTful students / this. So if I'm passing in the ID in here, it should say I couldn't find it or something. And my API died. Something else is going on. Let's investigate. Let's get to the bottom of it. Students controller. and it's communicating with iStudentService. Student service should be still singular, and then this is post student ID. Student ID. It's probably one of those little teeny tiny issues that something is spelled wrong or whatever the case may be. Okay, we have only 51 tests. By the way, let's just run everything just to make sure we don't have anything funny in the mix. The one thing that should fail, or all failures should be basically on the acceptance tests layer, which I'm going to come back to. But due to the time of this video, 3 hours, 4 minutes, it's probably better to wrap it up a little early and then make some announcements about who's going to be taking care of the next operations. All right. So we have one problem in here. Okay, that makes sense. Invalid input parameter name update date. Okay, so this guy here is having issues. Let's see why this guy is having update date is the random date. And the random date, let's see. So we have one issue that's going on here that we didn't know about. This is coming from here, update date, storage student. Oh, let's see. So this update date, did we clone from random? Yeah, we cloned from random, but random has changed because inputs. Yeah, that's a good catch. Let's see if that would work. There you go. This passes. Good stuff, good stuff, good stuff. I don't think that's why our API was failing, but I think we're good in here with this one. All right, let's run this guy again and let's see what the heck is going on with our API. Our API has something wacky going on with it. Let's also make sure that we actually have a database that's generated for us. Because if there's no database, then this is all, what's the point, right? So this is OtripleS DP tables. And here is the students, view data. There is no data there, obviously, and it's all good. Okay, so that means that we probably have something wacky with our could not get a response API/students, and we did a get and it didn't like it. What if we did a delete? Would delete work? Let's see. Delete. Could not find student with ID. So this one is working fine. Not found student exception. Right? But the post is not very happy. The post is not very happy. Let's see why the post is not API/students. Yeah, the post is breaking us. Let's see why the post. What's wrong with the post? Student controller. Post. Go. Is it the from body thing? Is that what's breaking us? Let's take that from body thing out. I don't like it. I don't think we need it really. Post student async. Let's go there. I think that might be it. Who knows? Ah, it might be it. Or not. Or not. Something is... Okay, something downstream is breaking us. Let's see what happened. Couldn't get a response. Let's see what the deal is. So this is register student F11. Validate on create. So this is the validation, and then there's... Oh, so we're blowing up on create. Fantastic. Let's see why it's blowing up on create. We're getting to the bottom of it. Okay, so there's this guy, validate student, student ID, and it should be throwing, so validate student ID. If student ID, you go with invalid student exception, and it should throw that. And we should be handling that in the exception. So invalid student exception should be going in here and throwing a validation exception. And maybe on the post we didn't handle generic exception. Let's see what's going on. Controller. Okay, so we're throwing an exception that this guy didn't know what to do with it. Student validation exception, bad request, error message. Student dependency, student serves. Okay, we're going places. Let's see. Here's another post. Jumping from here to here to here to here. All of this is good. Throw create and log validation exception. Does create and log doing the right thing? Throw create and log validation exception. Okay, and this guy is throwing an invalid student exception. So this is create and log validation. Throw create and log validation exception. Student validation exception. And the service is handing that over to the student controller. And this guy should fall right here, student validation exception. It's hitting all the right notes, except student validation exception. Okay. Let's see if we can get to the bottom of this. So throw new invalid student exception. And this guy went in here. And then it dies after that. That is very weird. That is a very weird exception. Maybe it's something with my computer. Let's just restart the world. Could be. OtripleS. Yeah, that is very weird. That's something I've never seen. Let's see what happens here. Okay. Okay. And this guy, post. Huh. Throw create validation exception. And then the controller is handling none of it, which is funny. Okay, if that's the case, what we actually can do, we can go here and say catch exception X and throw X. And this guy will tell us where the wacky stuff is. Because that's basically an exception that we haven't wrapped up properly. Otherwise, we would have known. So this is a post. Jump, jump, jump. Nope, it didn't even go that far. Student, invalid student exception. Yeah, we're gonna debug this together. We're gonna get to the bottom of it together. Invalid student exception should be here. Student validation exception. Log error, and then this guy says return. No, this is fine. This is still fine. because we're saying return, but we're throwing, so that should be fine. And our tests approve of that. Students controller, and we're hitting the right controller nodes, yet the service just dies. Post student async, value task action result. Async post put student async and then delete student async. Okay. Okay. And the get by ID doesn't work as well? Is that what I'm hearing? The get by ID, let's generate just a random ID just for funsies. Because looking at these, it might actually give us an insight on what's actually broken. So if I do get by ID, it breaks my service. Okay, so that's one. And if I do delete by ID, delete by ID response, could not find student with ID, blah blah. The difference on delete by ID is that it does not do a try catch or on anything. And this guy is supposed to be returning an action result. Yeah, this is the only one that doesn't have. Okay, so it's not this case at all. It's definitely not this case. Student service exception, student dependency, student validation exception. All of these are happening. And I don't think I have reached even that far. This is the student validation exception. Didn't even reach that far. And we're calling student service. Did we resolve this student service to the right? We obviously did because, let's see, I student service. So this is resolved right. Now we're going to start doubting everything until we find what the problem is. But we're definitely not leaving here today until this is figured out. So service exception, register, delete student async, and sticking the student ID. It's probably something that's more generic than it seems. This is async, all of this is good. Let's look at our exceptions and what they're doing. This is try catch, returning value task, student, and it's awaiting, returning student function. Not that it matters, but naming convention as we go. And all of this is throwing. All of this is throwing, and all of the tests are approving. There's no copyrights in here. Let's add that real quick while we're at it. And this is a partial class, and we're going that far. So as far as the service goes, this is good. The student's controller, however, API/controller, students controller. Unless our original control, unless the APIs have changed. Let's see what the compare with unmodified. Maybe something happened with the library that caused this to be. A second. So if I go like this, no, because I closed my my ID, so that's not gonna go back. Okay, let's take a look here. In a normal, there might have been an upgrade to the library that caused this. Let's just go and see. Scholam, controllers, student controller, controller base. This controller base might have been upgraded, and that's why. I don't think really that's the case, but let's see if that's Controller base, that means locked is out of question. The locked exception is out of question, so let's put that out for now. And then let's run our stuff. From here, yeah, it's basically anything really. Yeah, that's not the case. Something else is causing our system to fail. The easiest thing we could do, API controller route API controller. Let's make sure route API controller. This is all good. Students class, iStudent. Right. I wonder, just out of curiosity, because you never know. Let's call this something else. Don't think really it's the case, but it's worth the try. So this is a controller. This is API controller with read-write actions. Students controller.cs. So all of this is good. API controller. Yeah, I don't even think it's the route or any of that because students controller. It's something in our exception. So try catch. Try catch. Let's see. This dot student service register. It's also definitely not the IDs or any of that. So that's that. Might be a very, very subtle thing. iStorage broker, iLogging broker, iDatetime broker. All of this is good. And this is get by ID. And it just breaks it. Read. Let's see what the console says. It's a 500 exception. This is raw JSON. This is all good. Identity, user ID, all of that is great. And in post, by the time we get here, if I do a post in here, take this guy out. We seem to be hitting the right note. And the student is coming in full shape. It should have a recent updated date and a recent created date, which is the case in here. And then it's something with the exceptions that we throw that's throwing it off. All right. Try catch, throw exceptions. Register student async. All right, let's see if we get that far. I think we do. I think it's when we throw the exception is when all of this gets really wacky. So this guy like this, yeah, it definitely went that far. And immediately as soon as it ran into issues. All right, does the student model have anything weird in it that I don't know about? No, it doesn't. It has an ID, user ID. There's no magic going on there. It's all good. Hmm. System private.core lib. Okay. What if IIS Express is being funny? And this guy will give us the logging actually, so it's goal grade. So let's go here and do this. Oh, this guy's running on a it's running on a different port. Okay, this guy died. What did this guy say? Content root stack overflow. Yay, we have stack overflow. Why do we have stack overflow? Something in our validation is doing something really wacky. Let's see. Validate student ID. Stack overflow. Oh, are we handling our own exceptions over and over again? That would be funny. This is student validation exception. Yeah, we definitely are throwing, let's see. Already exists invalid student exception. Invalid student exception. And this guy here, student validation exception. So we're throwing student validation exception. Oh, the controller itself must be doing something fun. Let's see. So this is student validation exception. Stack overflow meaning that we are doing something really funny with the exceptions. Yeah, so if I run this guy, and then we hit invalid student input exception, and this guy's getting invalid student input, and it's going inside this guy. Yeah, the logging in here. The logging is doing what? Log error. Ah. The log error is basically log calling itself. How fun is that? Isn't that fun? So this is exception dot message, and then you're passing in the actual exception. Okay, fun stuff. All right, we fixed the problem. We figured it out. We figured it out. So now this guy's gonna fail for all the right reasons. Here you go. Run, and parameter ID is bad. So let's go and create a GUID. Copy that. Let's put that guy in here. There you go. So we can put in whatever bunch of IDs we want. And I don't know, identity number 1234, user ID 1234. We don't have anything on that yet. And then this is Hassan. Last name, middle name, birth date 1985, 9/27. And gender, I don't know what 0 is, but I hope it's dude. And here you go. And that should post something in the box. So this is post. So successfully posted the student in the database. And now we want to update that student. So we're going to go to put, sorry. And we're going to keep the created date as is. We're not going to change the created date. The one that we're going to change is the other date. So in here, instead of that, I'm going to say last name Habib. Yikes, Habib, like that. And if I post, that guy should be happy. So parameter name updated date. Updated date's not happy with the updated date. Let's see why it's not happy with the updated date. Invalid student parameter name updated date. Okay, updated date is recent. Why is it not liking the updated? You gotta try things end to end. If you don't try things end to end, you're gonna run into problems, and that's why we're doing that. We'll take extra time, maybe an hour or two, and just make sure things work the way they're supposed to work. It's called due diligence. By the way, forget to add a copyright in here. Let's go ahead and add that. And then updated date. Okay, let's see all the places where it doesn't like updated date. And we will fix that. All right, let's follow this guy. Let's follow this guy a little bit. This guy, we're trying to update, so this is modify. And then I'm going to try to hit that guy. Slash students put invalid student parameter name. Did it even hit the right modify student? Ooh, am I calling the wrong thing? In the modify, I'm calling the wrong thing. I probably am. Register, yes. So this is modify student. See, testing end-to-end is very important. I'm actually surprised because, you know, for people who have pushed the other endpoints, you have to test everything. You know, if I have to find about an issue like this while 3 endpoints are already in place, that's just not right, right? We gotta make sure that things are in place. Anyway, so it updated my name, and then if I put in here m dot, it should update again. And if I do get by ID and take that ID out, all right. So this is a full feature end to end. The modify. Let's play around with these things. Like say if this guy is empty, and I do a modify, I do a put, it should come back and say no, this guy is invalid. Let's take out the ID in here, and let's do that. You gotta try things around, right? So an invalid parameter value, so you can't have that empty. If I put that as null, you gotta play around. You gotta try things out and make sure things are working. First name is invalid. And the dates, let's say the created date, we monkeyed with the created date, so that changed the created date into something else. Doesn't like that. Created date is bad. And then if you try to monkey with, I think updated by is fine. It should let me do that, right? Because the person who's updating could be different than the person who's creating. But if I change this guy is going to be very mad. Say, nope, the created by is bad. So this is a good feature. This is full feature end to end from the controller to the storage worker. Like I said, not all of them are that hard, but definitely the modify takes a little bit of time, and I have no problem doing the modify every single time. But in order for you to get accustomed to industrial software engineering, building things end to end, you gotta do something like that. Anyway, fix issue with logging and controllers. All right, we have that. I hope I didn't still have that commented for students. Did I still have the locked commented? I don't have the locked commented, so this is good. All right, perfect. So this is that controller and finalization of modify student feature end to end. Right. So let's go and push that. All of that goes straight to master. And that's pretty much it. That's one full feature for people just see, and you know, and I know it took 3 hours and 30 minutes, but it's totally worth it. You know, if we're building something for the children, you know, it has to be really outstanding. The code has to be clean. The code has to be, you know, world class. The code has to have all the right stuff in it. If you go and look at the commit history, you'll be able to see in here the fail pass, fail pass, fail pass, and all the kind of stuff. A lot of people say squish commits. Please don't squash or squish your commits. Don't do that. Keep your history. Tell me what happened. It doesn't really cost money to have a bit more commits in here, so we should be good to go. Now let's talk about, so that discuss student model. I'm not going to close that yet because there's still a couple of things that are still lingering in the air. But from a teacher perspective, I'm going to send another announcement very shortly to outline what we think a student should be. It's probably going to end up being very, very similar to the student model, except for, an employee number instead of registration number, like my friend here said. But other than that, everything else should be pretty much the same. I'm sorry that this is to announcement, but because of the length of this video, I will set up the final model that we need to work with. I will go back and clean up all the stuff that, and I'm gonna, give priority for people who have been interacting with me, because I know I have assigned some tasks to some people and they've never contributed to the project, so I'm just gonna assume that they have some issues and they're trying to work with their issues. So whenever you're available again, let me know and I'm gonna assign tasks to you. But other than that, we should be good and dandy. So we're gonna start the teacher. Stay put. I'm gonna be sending, the assignments tonight. And if you have any questions or comments or concerns, please feel free to reach out. And I'll see you next week. Thank you so much.